Today, there is much excitement about self-driving cars. But back during the Vietnam War, the Navy had an aircraft that could virtually fly itself. After dialing in the coordinates, a pilot could rest assured he and his payload would arrive right on target. It could even land itself on the deck of a carrier. With all its advanced features and its rock-solid design, this aircraft served double duty in the U.S. Air Force for close support and treacherous rescue missions. Conceived by the brain trust of legendary aircraft manufacturer Vought, it was an aircraft for its time and ahead of its time. This was the A-7 Corsair II. By 1963, the U.S. was heavily invested in the Vietnam War. A year earlier, Kennedy had signed the Foreign Assistance Act, offering military aid to nations on the edge of communist expansion. South Vietnam was embroiled in such a conflict as hostilities intensified with the communist North. The Americans made good on their promise, providing the South Vietnamese with equipment, training, and a growing number of military advisors. With an all-out war almost inevitable, the U.S. Armed Services began prepping for battle. The Navy was looking to replace their aging Douglas A-4 Skyhawk. It was a small, subsonic bomber, capable of carrying the same payload as the B-17 bombers of World War II. The Douglas Aircraft Company had manufactured the original A-4 Skyhawk, and they were eager to remain the Navy's light bomber manufacturer. They offered the simplest solution: build a better A-4, and they hoped to circumvent the usual competition for such contracts. However, other manufacturers, including LTV Aerospace, would not stand to be shut out of the process.
The Douglas Company sold the Navy on a non-competitive buy of the A-4 Skyhawk. It was to be the A-4 D6. Our folks got wind of it and reminded the Navy that this probably ought to be a competition which Vought could participate in. And it was.
I said, we ought to compete for that. So I went to Washington and I talked to George Spangenberg, who was in charge of evaluation. I said, we want to compete for that, George. He said, okay, we'll have a competition, but he says, you're not going to win. I said, well, let's see. So we went back and I put together a team, which I think was one of the finest teams I ever had.
LTV and its predecessor, the Chance Vought Aircraft Company, had decades of experience producing a long list of fine Navy aircraft, from the VE-7 Bluebird to the F-4 Corsair to the F-8 Crusader. LTV was fortunate to have an engineering and management team with intimate knowledge of the Navy's unique requirements. Saul Love joined the company in 1943, and he played a part in every aircraft design since the F-4U.
The A-7, which was the absolute highlight of my career, the proposal was led by a gentleman by the name of Saul Love, a very tough but charismatic individual. He used to scare people to death. And I mean, literally, he was one of those tough drivers. I did a cartoon series called Saul Says, because everything we did, when you worked with Saul, nobody would make a decision until they got the word from Saul.
My job, I thought then and still is today, is to get people to do the job the best they can. And I used to tell them, don't do it the way I would do it, because you're not me. Just go do it your own way. Just make sure that your end result is what I would want it to be.
In designing the A-4's replacement, LTV had to achieve one very important objective for the Navy: commonality.
The ground rules were primarily, other than mission, This had to be very compatible. You got many points for compatibility with the current airplane you're building.
As LTV forged the Navy's next light bomber, they were also fortunate to have an excellent foundation to build upon, the F-8 Crusader.
The A-7, in a large sense, was a derivative of the F-8.
The Vought F-8 design was so sound. It was an outstanding fighter, had good maintainability, it was good around the boat, and the basic parameters of the airframe were really acceptable for naval operations.
Although the A-7 was based on the F-8, they were very different aircraft with different requirements. The F-8 was a supersonic fighter with a monstrously long J-57 afterburning turbojet. The A-7 needed a less powerful engine to be able to execute lower altitude bombing missions with accuracy.
The Navy gave us the engine. We had no choice to house that engine, and that engine drove the fuselage, drove the length.
You look at taking the F-8 design and take out the J-57 turbojet, eliminate all that length of afterburner, you can shorten the tail immensely. Then you put in a turbofan, which is a little bit larger diameter with a little higher bypass, and you take the fuselage, which is rather tight, and you can beef it up and kind of box it out to make a little more room for fuel and avionics. Because you shorten the tail, you also have to shorten the nose. So that accounts for a much shorter airplane. It's going to be much easier for deck operations and hangar bay operations.
It's not surprising that the A-7 was fitted with a very different wing than the F-8. As a dogfighter, the F-8 needed speed and agility, while the A-7 needed to carry a truckload of bombs on its wings.
We were very happy with a high-winged airplane, the ability to carry stores that other airplanes couldn't carry or had difficulty carrying.
The F-8, you take the wing, which is already a superior fighter wing, but it's really optimized for high-altitude supersonic, but we already said we're going to go subsonic turbofan. So you take a wing that has about a 42-degree sweep at the quarter chord point, flatten that out to about 35 degrees, yet you use the same technology of a wing planform that has leading-edge droops for slow-speed flight.
The Crusader was so long that it was difficult for pilots to see the deck as they came in for a landing. A unique feature of the F-8's wings was that they were of variable incidence. That is, they pivoted up and down into one of two positions to improve visibility. It was a feature that could be stripped out of the shorter subsonic A-7.
The A-7 wing was optimized by being much larger with some of those changes that it could fly slow enough with the shorter fuselage at the angle of attack necessary and still have visibility and come aboard the boat without having to have the variable incidence.
In order for the A-7 to be successful in the field, it not only needed to stand up to the rigors of war, it also needed to be easy to maintain.
We had a couple objectives. First of all, we wanted it maintainable. Secondly, we wanted it reliable. So we set out to see what we could do to minimize the maintenance man-hours per flight hour. And one of the things we decided was we were going to have an avionics bay right behind the cockpit, and you could open those panels pretty fast and pull all the avionics out. And part of maintenance is the time and access to the stuff that goes to pot most of the time.
Going from the F-8 to the A-7, LTV engineers made a big improvement for engine maintenance.
The F-8, in order to get the engine out, we had to pull the aft section off. It was tied with 4 bolts. And that was a pain in the neck. So one of the guys, Max Sire, I think it was, said, you know, we ought to try and do this without pulling the tail off. So I turned to Jesse Santa Maria and I said, Jesse, what can we do? So he went back and looked at the design, finally got enough tail clearance. So we ended up with a quick removal bottom panel on the aft fuselage so you could just slide the engine out. And that meant that the bulkheads that had the fin and the horizontal tail to them, we had to have a connection across to hold them in place while the engine was out. These were all things we did to design for maintenance man-hours per flight hour.
Although commonality was an objective, with all of the differences between the A-7 and F-8 designs, one has to wonder if any trace of the F-8 was left behind.
The common parts were mostly internal. Actuators, there really weren't that many, to be honest about it.
There might not have been many common parts between the two aircraft, but they shared one important feature. They were both excellent designs. LTV knew they had a winner when they submitted their proposal.
When Vought submitted that design, it clearly became the winning design with all the lessons learned that the F-8 had from Vaught's many, many years in naval aviation.
We submitted a proposal that guaranteed maintenance man-hours per flight hour. It guaranteed minimum approach speed, Vmax, load carrying, fatigue requirements, and we fixed price with penalties for failing to meet all the performance requirements. And they convinced me that I needed to make a movie. I said, not me, and Connie Lau, who was a dear friend, who was the original program manager and who said, you're gonna make a movie. So I made a movie, and when I was part of the proposal.
We were so certain of the win. We called ourselves a winning team, took pictures.
As good as the A-7 proposal was, one of the darkest days in American history might have eclipsed the entire program of the Texas-based manufacturer.
That was 1963, and we won the competition. But Kennedy got assassinated in '63 in November, and they would not let him announce the winner. And they wanted to change it because of Kennedy's assassination.
We thought that we were gone because Kennedy was killed here, and there was no love lost between the East and the West in this country, and especially when you're talking politics.
The A-7's future was in turmoil. However, clearer heads would prevail at the Navy Bureau of Aviation. Politics were put aside, and the best interest of the nation and Navy were put at the forefront.
Two people stopped that. George Spangenberg, who was charge of evaluation, and Hank Surstead, who was a Navy program manager. They refused to concede. And finally, in 1964, March, they announced the winner, and we were the winners.
In recognition of its great potential, the A-7 would share its name with a fine lineage of Vought aircraft, all called Corsairs.
The original Corsair was the O2U, built in 1926. Another follow-on version, the O4U, was a Corsair that it could be called the Corsair II. Then the F4U was the Corsair, maybe the Corsair III. Goodyear built some of the F2G1s, the beefed-up Corsairs. Maybe those were Corsair 4s. So this thing may have actually been the Corsair 5 from a technical standpoint, but Vaught's penchant for naval names, Corsair, Cutlass, Pirate, kind of fell in line with it.
The Corsair also had a less complimentary nickname, the Slough.
The rather stubby, less elegant look compared to the F-8, which was really the last of the gunfighters, and rightly so. It was referred to as the Slough, short, little, ugly, you know.
September 26, 1965, was a key moment in the A-7's history. It was the day the A-7 would spread its wings for the first time with its first flight.
The first flight we ran at Hensley. John Conrad, the pilot, and I'm at the tower, and John takes off. Well, it's fine, it's fine. Pretty soon he says, I'm coming back in. He had a car that had a lot more in it. He landed, and I said, okay, John, what's the problem? He says, there's a tail buffet. I said, well, what could cause that? Because we sure didn't have that in an F-8. So I called George Upton, who was chief of aero, and he came over. I said, what do you think, George? We had to put a flap on the A-7 because it didn't raise the wing. It was fixed.
LTV would iron out these initial problems. As part of LTV's contract with the Navy, the aircraft manufacturer made a long list of guarantees. Every single one of them were met or exceeded, save for one. But it was a penalty that paid off for LTV.
There was a penalty for the weight. We paid $275,000 in penalties because our wing was heavier, which made the airplane heavier than was called for. We paid that price, which allowed us in later years, we could carry a lot more stores on the main wing beam.
One of the most remarkable aspects of the A-7 program was just how quickly the aircraft progressed from the drawing board to the air and into service with the Navy.
It was about 20 months from contract initiation till the prototype flew, which was a very quick time. Some had actually done faster, like some of Kelly Johnson's amazing thing, but for a tactical airplane in that time frame, 20 months from contract to prototype flight was amazing.
A little over a year from first flight to delivery. 16 months it was in combat, which I can't conceive of over 20 years for the F-22, from contract award to delivery of the first airplane, over 20 years. What do you do for 20 years? The F-35, gonna be about 15.
The need to begin rolling aircraft off the assembly line was undeniable. In 1964, the same year LTV won the contract, the fallout from the Gulf of Tonkin incident led the U.S. into a full-scale war in Vietnam. The A-7 became operational in 1967. It was first distributed to A-4 squadrons on both the Atlantic and Pacific coasts as part of a transition and upgrade to the new lightweight bomber. Though it quickly became a favorite amongst pilots, the team at LTV recognized the first models would need some adjustments to deal with the real-world battlefield conditions in Vietnam.
I said, there's two things that are wrong with this thing. The engine doesn't have enough thrust, and you ought to put in a bigger engine, but you're going to have to make that change because you set the engine requirement at the beginning. And the second, you don't have the ECM gear in it, and this airplane is going to need it over in Vietnam. No, we don't need it. About a quarter of the way through A-7A, the Navy came in, and at this stage of the game, the program manager was Tom Gallagher. He says, Sal, he says, we're going to have you put in provisions. I said, you're going to stop the line? Yeah. I said, it ain't fixed price anymore. He said, no. So the A-7B was established.
The ECM gear, or electronic countermeasures, could jam or deceive enemy radar, and a more powerful engine helped with the hot, humid jungle conditions, which could make for sluggish takeoffs.
The A-7As flew with the TF-30 P6 engine. That put out about 11,200 pounds of thrust. Pretty good for the airplane at the time. The A-7B had a modification with what they call beep flaps to help reduce drag on acceleration and get some better takeoff and climb performance. And they used the TF-30 P8 that bumped the thrust up to about 12,300 pounds of thrust.
Like a father watching over his newborns, Saul Love deployed with the first A-7s to Vietnam, or at least he attempted to, before the North Koreans shattered the Navy's plan.
I started then with the A-7 deploying with the 1st Squadron to Tonkin Bay, and one of the things I have in my office is Tonkin Bay Golf Club, I guess it is. And I'm on the Hancock, we're on the way, and you remember the Pueblo incident, where North Korea took over the Pueblo, and the Hancock gets orders to change their deployment to the Sea of Japan with the A-7s. And the skipper calls me, he says, you got a choice, Mr. Love. He said, you can take a chopper over to the Ticonderoga and go to the Tonkin Gulf and then get to wherever you're gonna go. Or you can stay on the Hancock and maybe we can offload you at Kubi. So we chose to take the chopper over the Ticonderoga rather than end up at the Sea of Japan. And the Admiral flies over with his band. We're going to the Tonkin Gulf. The Admiral's there with the Navy band. So I ended up spending the night in the wardroom of the Ticonderoga, but that's how much I missed the first deployment of A-7s.
The A-7s ultimately arrived in Vietnam. They immediately began taking over for the A-4s, which had been spearheading the Navy's light bomber attack missions.
When they initially deployed to Vietnam to begin replacing the A-4, the light attack strike mission that the A-4 had been doing exclusively took over that mission, but could do it with a much more reliable platform, with better accuracy, better on-station time, better range, and better maintainability. The A-4, man-hours per flight hour, was something like double or triple what the A-7 was. So overall, all the way around, winning in all categories.
The A-7 was an exceptional aircraft and filled the Navy's need for a light bomber in the jungles of Vietnam. It was so impressive, some wondered whether it might serve double duty with the United States Air Force. They were already using the Navy's aging A-1 Skyraider as close support aircraft. So why not use the Navy plane for the Skyraider's replacement? It certainly fell in line with Secretary of Defense McNamara's focus on aircraft commonality.
The big push in the early 60s that really was driven heavily by Secretary of Defense McNamara when he took office in January of 61 was they wanted to have commonality amongst platforms. The thought was, for sure, if you have the same aircraft, you'd save a lot of money.
Although requiring the services to use the same platform could be a money saver, it could also be a disaster. Under the TFX program, the Navy was supposed to adopt the F-111, an aircraft largely based on Air Force requirements. It turned out to be a formula for disaster. The Navy F-111B was overweight and underpowered and canceled after just 7 aircraft were constructed. Would the Air Force have better luck adapting the Navy's A-7?
The problem was the Air Force leading it didn't ever seem to work out. But by the time the valve study was completed and the Navy was running with the A-7 program, the Air Force saw the promise in that airframe as new technologies, very efficient airframe, great bombing capability, and they determined that we should get those too. So the Secretary of Defense assigned the Air Force a program in 1965 to work with the Navy to develop another version of the A-7 for the Air Force's use.
The Navy bought it. The Air Force was forced to buy it by DOD, but it turned out to be one of the best buys they ever made, a screaming bargain. The airplanes were delivered for around $2 million a piece.
The Air Force would take an already exceptional A-7 design and make it even better, insisting on a whole host of electronic upgrades and more powerful engine.
The A-7's early version was really a replacement for the A-4, a pretty basic jet with some modern technologies coming in, some bomb intervalometers and things like that, and a TF-30 engine, pretty good technology for the time. But the Air Force got involved and said, we'll have a common airframe, we'll use this, but we want a lot more changes.
Adapting the A-7 design made sense. The Air Force knew the A-7 was a solid airframe to build upon, and modifying it would rapidly provide them with a modern-day replacement for the Skyraider. Still, the services had an inherent reluctance to borrow aircraft from each other.
Over my years in the industry, I discovered the personality of the services. The guy who has a bunch of money operates differently than a guy that doesn't have much money. The big Air Force pays more for everything. Now, I'm not from an Air Force background, but I come to know the Air Force as the biggest committee at the longest table on earth.
The Air Force was very demanding about the features and performance it expected from the A-7D. Instead of frustrating the company, they pushed the engineers at LTV to deliver a state-of-the-art aircraft.
I was the lead designer on the A-7, and I sure absorbed all the heat from the Navy and Air Force on the A-7DE. The Air Force program manager, he wanted a full digital airplane. Now, there wasn't one flying it that day. And he also wanted a heads-up display. And so I sent John Conrad over to Europe to fly the heads-up display in the Buccaneer, which was an analog. And nobody in this country would bid on the thing other than a best effort. The only one who would bid on it was Elliott's in London. They had developed the one on the Buccaneer. So we placed a contract with them, and I will tell you, they did an outstanding job on that thing. Although we had some fun in the process because interesting country. Come tea time, everybody shuts down.
The A-7 was the first all-digital electronic airplane. It had the first HUD, the first head-up display. It had the first digital nav-WEP delivery system that worked. The A6 was the A6 had. It wasn't working on the A6. Their development problems continued on. The A7 was working immediately.
A whole host of new technologies went into the avionics. This had to do with a forward-looking ranging radar that had terrain following, terrain avoidance capability. A very complex weapon system involved a miniaturized digital computer that was kind of the first of its kind, a very complex HUD system that was driven by the computer that showed flight symbology with a velocity vector, pitch lines, so that the pilot could look out the window straight ahead and get information about altitude, airspeed, dive angle, flight path, and then even have information from radar warning receivers about potential missile threats displayed right in his head without ever having to look inside the cockpit. And that was important because they were developing what we would call today the HOTAS methods of flying, hands-on, stick and throttle all the time, never having to reach in to change things around. So that level of technology was put into the A-7 under the Air Force's guides.
Seeing the advanced avionics and weapon system in the proposed USAF A-7D model, the Navy wanted to take advantage of the same technology for themselves and incorporate it into their own aircraft. These would become the A-7E models.
The Navy was saying, great, we'll add some things here too. We'll add a few more things for carrier suitability. And in short order, you had the A-7 in two major models, the A-7D and the A-7E. And not much difference internally for both airplanes.
Both the USAF Corsairs and the new Navy models would take advantage of more powerful engines.
When the Air Force made the modifications to build the D model, they went another step further with the Rolls-Royce Spade design, TF-41, and that one took the thrust up to about 14,500 pounds of thrust. Pretty significant increase. And later on, when the A-7E was built by the Navy, they just took a little tweak on the TF-40 design, and it was a TF-40 A-2 that another 500 pounds, and that rounded out at pretty close to 15,000 pounds of thrust. So from the original A to the final version E, you're talking about a nearly 40% increase in thrust overall. So pretty good specs and maintained pretty good fuel efficiency the whole time.
The avionics were what really made these two new A-7 models stand out from the crowd. Pilots could leave the driving to the aircraft as they sped to the target.
I think it was one of the finest airplanes we ever built. The Navy loved the airplane. They could dial in a point they wanted to go, set the compass and forget it because it would automatically adjust the thrust and everything else. And we discovered that it was more accurate than some of the geodetic surveys. They found that some of the geodetic surveys at Yuma were wrong because of what the airplane did with the platform.
The pinpoint bombing accuracy of the new A-7s would make them the pride of the Navy and Air Force and the envy of the aerospace world.
Everybody was surprised at the accuracy of the bomb delivery. I remember I had to make a presentation to DDR&E in the Pentagon, and he said, "What makes you think you can do this? I've been trying to do this on the GD supersonic bombers." He said, "I can't get them to do it." And I said, "I'm not GD, I'm Vought."
The Navy's A-7Es began arriving in Vietnam in May of 1970. They were an excellent upgrade for the already outstanding A-7As, still pounding away at enemy forces. The A-7Es' avionics and weapons delivery systems made them well suited for precision strikes in close support missions. Capable of carrying a wide range of ordnance in all weather conditions, day or night, the A-7Es were a versatile multi-role aircraft.
You talk about air-to-ground capabilities, the A-7 was designed to carry, for the most part, I think, anything in the air-to-ground inventory that existed at the time. It could drop anything. Additionally, the air-to-ground mission would require strafing at some point.
The guys over at Thompson Newt would tell me what they'd do is they'd go from the carrier, they'd drop down to sea level and start the gun and just wipe out the and then fly back up again.
So the early version had a pair of Colt Mark 12 20mm cannon with about 500 rounds of available. Later in the A-7D and A-7E modifications, that would be switched out to the unbelievably effective and really fun to shoot. M61A1 Vulcan, hydraulic powered, electrically fired 20mm cannon. The cool thing about that weapon is that cockpit in-flight selectable. You could pick 4,000 rounds a minute or 6,000 rounds a minute. And frankly, 6,000 rounds a minute is a lot of fun, but you got an increased chance of jamming. And if you can't hit it at 4,000, 6,000 rounds a minute, it's not going to help you.
The Air Force's A-7Ds would arrive later in the conflict. They would make a name for themselves, taking over for the A-1 Sky Raiders on Sandy missions, providing cover to helicopter crews as they attempted to rescue downed pilots. On November 18, 1972, Major Colin A. Clark led an 8.8-hour combat search and rescue mission to recover a downed F-105 Thunder Chief pilot. Taking several hits, his rugged A-7D was able to withstand the 12.7mm flak fire of enemy forces. Major Clark's courage would win him the Air Force Cross and his aircraft a place at the National Museum of the USAF at Wright-Patterson Air Force Base. It's not surprising, given its capability and durability, that the A-7 was well loved by pilots in both branches of the armed services.
I still talk to guys who flew A-7Ds and Es who just love the airplane. I have a letter from Bob Baldwin, who was one of the original F-8 pilots, who was at that time, after I retired, he had the 7th Fleet. He said, we're just bringing the A-7Es aboard, and boy, do everybody love it. So they were good airplanes, and they were reliable.
From all the people that I knew flying it, we loved it. It was a great airplane to fly, great weapon system, easy to understand and employ. It took some practice to really fine-tune it and learn how to finesse the airplane. It wasn't like a real hog to drive around the sky. He's pretty honest and very controllable. Around the ship, we had to be careful because you do have to slow it way down, and the engine response wasn't the best around. It didn't spool up like a turbojet would. So you did have to keep your power up and keep the thrust running to bring it aboard. If you got very far under power at all, the LSOs would give you the Eat at Joe's lights and you're out of there, because they couldn't let you kind of work the bottom side of the glide slope. But as far as flying it, I don't recall ever talking to an A-7 pilot that didn't really like flying the airplane. And the A-4 guys that transitioned to it all seemed to love it too.
I have stories of guys tell me that they'd get into maneuver, didn't know where they were, and they just hit the autopilot and the airplane righted itself. You just dialed in where you wanted to go and you went there. It was a good airplane. The Air Force liked it.
Looking for the things that are less desirable, when you consider the mission it had to do in the operational environment, it pretty much hit all the nails directly on the head. When you start getting into things that you might not like about the airplane, they probably fall into the esoteric creature comfort type of areas. For sure, it is a hot airplane. And there's a term we refer to on the carrier, we call it the barbecue pit, where the A-7s were usually parked adjacent to each other right in front of the island. And we're starting up and closing the canopies, getting ready for launch, as the F-14s are parked in a row around in front of us, getting ready to move to the cats first. And all the plane cabs are standing around roasting, and you're just sucking up all this hot air in a cockpit that's closed with not enough airflow from your engine to cool it down, as the fumes from the F-14s get pushed into the cockpit, and your eyes start to burn in water unbelievably. And if you look at movies around, once in a while you'll see planes parked in front of the island waiting to go, and you'll see the pilots sitting there like this, as if they're holding their... You're actually, if you pull your oxygen mask down and let the oxygen blow across your eyeballs, they stop burning. I mean, that's how bad it was. And you had to have that mask on so you're not sucking fumes. But that's a miserable few minutes waiting to launch in the barbecue pit. You can't go anywhere, but part of the game.
The Air Force and the Navy A-7s left Vietnam with impressive records. The Air Force A-7Ds flew a total of 12,928 combat sorties with just 6 losses, the best record of any U.S. fighter. The Navy A-7s were equally successful, hitting and destroying countless targets, including the Than Hau Bridge. On October 6, 1972, 4 A-7s carrying a combination of conventional and television-guided walleye bombs were able to break the bridge in half, knocking it out for the rest of the war. Like every great airplane, there comes a time when a new aircraft emerges with even more advanced capabilities to supplant it. After finishing operations in Vietnam, A-7Ds operating out of Korat, Thailand, were utilized in Cambodia against the Khmer Rouge. When they returned home to the U.S., the aircraft were transferred to the Air National Guard. Vought would reconfigure the A-7 into a deadly night attacker for the ANG under the LANA program.
Jim Reed would jump in the airplane, set it in the computer, jump in the airplane, take off, turn it over the computer. At night, 500 knots over the deck at night, come to the target, pull up, drop the bomb, come home, and Jim would never have to touch the controls till he got to back to Hensley. Now that's given the years I was on, that is an incredible avionics, incredible engineering feat. But that's the kind of people we had.
Though A-7s had a distinguished record in Vietnam, the Air Force still held a grudge about using a Navy aircraft for its missions. They were eager to develop their own close support aircraft and would choose the A-10 Thunderbolt II as the A-7D's replacement. The Navy A-7s would have a longer tenure and would participate in Operation Desert Storm and Shield in the 1990s, in important but much smaller roles compared to Vietnam. Even by the late 70s, a new multi-role fighter had been in the works, which would supplant the A-7 on the U.S. Navy's carriers.
By the late 70s, the A-7 was already aging out as a weapons platform and new technology were coming. The F-14 was getting along in its tooth already too, so a new jet was called for, and the fourth generation F-18 was beginning to roll off the drawing board. A very capable airplane with the newer technologies and the awesome F-4 engines. That was coming out, hitting the fleet in about 1983 timeframe. The transition plan was pretty much that A-7 squadrons would transition to the F-18, and it was a clean transition since they were both single-seat aircraft initially. If you look at the HUD design of the F-18, it's very identical to the A-7. That basic layout is pretty much how it works, and that's the standard.
Though the F-18 was a next-generation aircraft, the A-7 could still hold its own in a bombing competition, given its advanced avionics and weapons delivery systems.
In the early 80s, I can recall being at Cecil Field at a squadron picnic with VA-46 when we heard a really strange loud noise, and we all looked up and we saw the first F-18s in the break coming in to land at Cecil Field, and we're all just dumbfounded watching and said, they're here. And as we're watching them land, we're all saying, they're going to have to earn their spot at the bar. And in short order, we were having bombing contests. And at first, we were out bombing them because they had a new airplane that was much more capable, but they hadn't really learned it yet. Eventually, they'd be right in there and started winning some bombing contests. But the A-7 held its own for a while because it's just a really good bombing platform and very accurate.
Lieutenant Commander Michael Psycho McLeod had an opportunity to fly both the A-7 and F-18 for the U.S. Navy. He originally saw the A-7 as merely a stepping stone for the F-18, but the older aeroplane quickly became a favorite.
The F-18 was just coming out in '83, and I was right in the middle of flight school, so that was the way to go. Then, as I got to fly the airplane, I learned more about it. It was just a very honest, sweet flying airplane. And then the mission was fantastic too. Low-level attack. It has some self-defense capability with the AIM-9 Sidewinders. So it pretty much was a jack-of-all-trades airplane. Very efficient, good fuel specs, so you can stay airborne a long time, and great to fly around the boat. My last A-7 flight was at VX-5 at China Lake, just finishing up that 3-year tour doing test work. I like going to air shows and seeing all the restored aircraft at museums. The problem you have is that there's no restored A-7s. There's nothing out there flying around. So unless you can find one at a museum, it's a kind of a rare bird to get your hands on. I have a few friends that work here at the Valiant Air Command Warbird Museum, and They said I could come up and see the airplane and get up inside and take a look at the cockpit and visit where I used to work. Looks like it'll be a real fun thing to do today. Norm, how you doing?
Hi, welcome.
Good to see you.
Nice to see you at the Valiant Air Command.
Glad to be here.
right.
I'm glad you guys called. You're moving the A-7 around today, respotting the hangar?
Reclaiming certain parts of it, yes.
Well, look what I got.
Oh.
I don't know if you've seen one of these in a while.
Not a real one.
This is my A-7E pocket checklist that I used when I was flying at VX5 at China Lake. That was the one I carried with me in my G-suit pocket. I'd swap them out. If I was going out in the A-7, I'd throw that in the pocket. If I was going out in the F-18, I'd swap them out. But
This says A7, so
Yep.
you got the right one.
that's the one I was using, and I haven't used that thing in 27 years.
It looks like brand new.
A little dog-eared around the edges, but it's got some work.
So, I'm a little ignorant. What does automatic carrier landing do? You taking that plane lands, or how does
That's
that
actually, it's one of the things, the A-7 was one of the first aircraft set up, fully qualified to do automatic carrier landings. When it did the first flight tests, it went out with the A-7 flew with the F-4. The system is called the Spin 42, and it locks up the airplane, and the tractor beams essentially grab you, and the airplane flies itself to a landing right in the wires. Automatic power control, flies itself.
Just tell me some classified information.
Nope, it's run-of-the-mill equipment today. It's normal things.
Okay, this is amazing. Absolutely amazing.
We used to
The fact
test
you
them once.
survived is amazing.
Not a problem with the good machinery we had, but yeah, the automatic landing was something that you didn't do too often, but I can remember one night coming back really late, and I was beat, and I was just thinking, I don't know if I'm going to make a real good pass on this, and I called them up. They said, is the Spin 42 up? And they said, it is. Get the data link. I'll bring me home. I want to take an automatic landing.
You want to see your airplane?
It's out there in the hangar now?
Sure, it sure is.
Let's go see it.
Can I hold on this for a while?
Sure,
Carry this. You look at the
sure.
airplane. Come on.
Nice.
This way.
Here it is. Nice. Nice job. Excellent.
Thank you. These guys, everybody helps. Everybody works. Andy.
Nice.
Pleasure to meet you,
Nice
sir.
to meet you, Andy.
Tom.
Hey, Tom. Excellent.
So we're happy you're here.
Thanks for inviting me out. Nice work you guys are doing out here. This is tough machines to keep in this kind of condition. I mean,
Thank you.
with all the alloys and titanium, I guess corrosion is your worst enemy, but you guys look like you've conquered it. Great. So how long have you actually had this airplane here?
It's been here a few years now. Just finished restoring about a year and a half ago.
How long did that whole process take?
Some airplanes 4 years, some 2, some 1.5.
Wow. Keep
Yeah.
you busy.
Some 7.
Do you also restore the cockpit too?
This one, yes.
Really? Mm-hmm. Any chance I could take a peek in the office?
For special people, yes.
I haven't seen the inside of one of these things in 27 years.
You're special people.
Awesome. Let's do it.
Okay.
Great. Wow, there it is. Nice. Okay, some habits die hard, making sure the seat's not armed before you step in it. And never step on the seat if you can avoid it. Excellent. Much better visibility than an airliner, that's for sure. Climb in the cockpit and you do a sweep starting at the aft left console. You check your oxygen and G-suite connections, make sure those are in there. Go through all your avionics, engine controls, jettison circuits, gear handle, emergency power package, all the flight instruments. And that's the weapons delivery system for the early A and B models. Later the radar display moved down there. And before the more complex HUD, just had a kind of rudimentary combiner glass for bomb depression angle on a mill reticle you could set. The always friendly tail hook handle. Some tack-in, radios, navigation computer, and a glove box for some things. And way down here, the wing fold mechanism. Lift this handle up and there's a toggle switch in there to spread and fold the wings. All the important parts. Nothing like throwing the hook down on the way back to the ship, getting ready to land. Cool.
The A-7 is a particularly important aircraft. It served well. The pilots liked it. It executed everything a pilot asked it to do. The pilots that flew those things swear by it. So when we had the opportunity to grab that airplane, we wanted to restore it in its original configuration with the Death Head logo. So it took about 1.5 years to do that, but we're very happy with the results.
Good to go.
By the late 1980s, the A-10 was a decade-old platform, and the USAF was considering its options for ground support. The Vought team came up with an out-of-the-box solution. Why not use an A-7, the very plane the A-10 had replaced?
The Y-7F came out of a very aggressive effort by a couple of Vought people who responded to an Air Force request for a study of ground support machinery. And instead of responding with the study that they asked for, we responded with a proposal for what we call the strike fighter, which we took the A-7D airframe and put in an F-100 engine, much more modern engine, more thrust. And with the additional power, we could take off with our maximum loads. The airplane A-7 already carried an incredible amount of ordnance. We could honk that load off in far less distance and operate out of smaller fields. It allows you to deliver weapons with much greater accuracy, and is a much more economical airplane to operate. You can have lots more of them around, and numbers do count in wars.
The YA-7F could have been a rapid-fire solution to the USAF's needs. But it had one feature the Air Force couldn't live with. It was a Navy plane.
It was successful. We got the Air Force's attention, and we got a contract for 2 airplanes. We built the 2 airplanes. The airplane was flight tested, very successful. There were 2 elements that affected it. One was we stopped marketing once we got the contract, which is death when you deal with a Navy contractor with the Air Force, and that is they don't want another Navy airplane.
The A-7, a stable and reliable platform, continued to serve in the U.S. Armed Services into the early 90s. Other countries operated them for even longer. The Corsair IIs just missed out on their golden anniversary. The Hellenic Air Force A-7s were retired in 2014. 49 years after the first prototype flight. From 1918 to 2014, 96 years, Vought aircraft were in continuous use by the Navy and other nations around the world. Full credit for the design, manufacture, and development of this remarkable aircraft has to go to the Vought team behind it.
We had the best engineering department in the world. I want to tell you, I spent 2 years in the Pentagon, and I never met an engineering department as good as the one that we had.
I think the engineer design team at Vought really hit the mark. They were smart in that they took a lot of lessons learned from their early years and modified that into a new attack platform.
Hugely successful program. Everything was a delight because the company was a family. And there was simply no comparison in the way they operated.
The legacy of the A-7 is something the Vought family can be proud of. It was ahead of its time technologically and would influence future generations of aircraft. The Corsair IIs also had an impeccable military record. Flying in an A-7, a pilot knew that his aircraft was a partner who had his back during the mission and ensured he got home safely. Today, A-7s can be found in aviation museums across America, a worthy place to celebrate this great aeroplane and to teach the next generation about its storied history.
In 1967, the United States Air Force was at a crossroads. The dominant philosophy of the time, driven by the Cold War, was that faster and higher was always better. The skies were filling with sleek, supersonic interceptors and bombers, designed for a high-tech nuclear confrontation. But halfway around the world, in Southeast Asia, a low-tech, grinding war in the mud was proving this philosophy fatally flawed. America's most advanced jets, the F-4 Phantom and F-105 Thunderchief, were proving to be terrible tools for supporting troops on the ground. They were too fast to see the enemy, too fragile to withstand ground fire, and their time on target was measured in seconds. The most effective aircraft for the Close Air Support Mission, or CAS, was a prop-driven, piston-engine relic from a previous war, the A-1 Skyrader. It could fly slow, carry a massive bomb load, and soak up incredible amounts of damage. This realization sparked a quiet but fierce debate within the Pentagon. A small, forward-thinking group championed a new, purpose-built aircraft. This AX, or Attack Experimental Program, called for a jet that was, by the standards of the day, a step backward. It had to be slow, simple, cheap, and above all, survivable. Two companies entered the fly-off, Northrop with its YA-9 and Fairchild Republic with its YA-10. Fairchild Republic had a special pedigree. It was the descendant of the company that built the F-14 Thunderbolt, the legendary Jug that had perfected the ground attack role over Europe. They understood the mission in their corporate DNA. Their YA-10 was an uncompromising, brutalist piece of engineering. It was designed to do one job and do it well. The footage you are about to see, captured inside the Fairchild facility in Farmingdale, New York, is the very genesis of this machine, filmed approximately 200 days before its first flight. Here we see the assembly of an aircraft built around three principles. The first is lethality. The centerpiece of the entire design is the General Electric GAU-8 Avenger cannon. It is a 7-barrel Gatling gun, 19 feet long, firing 30mm armor-piercing shells. The gun is so large and its recoil so immense, the entire aircraft was literally designed to accommodate it. In this footage you can see the massive weapon being integrated, a process that dictated the plane's final form. The front landing gear is offset to the right, a visible compromise because the gun's firing barrel sits on the absolute center line of the airframe. The second principle is survivability. We see the core of the pilot's protection, the 1,200-pound titanium bathtub. This armored shell would encase the pilot, designed to withstand direct hits from 23mm anti-aircraft cannons. We see the engines being mounted high on the rear fuselage, a brilliant design choice. This shields them from ground fire from below. and also places them in the shadow of the wings and tail, protecting them from heat-seeking missiles. The third principle is simplicity. The YA-10 was built for a rough life on the front lines. Its broad, straight wings provide immense lift for low-speed flight and allow it to operate from short, damaged, or unpaved airstrips. Many of its parts are interchangeable from left to right, including the main landing gear, the rudders, and the elevators. This dramatically simplifies field maintenance. What you are witnessing in this rare film, the marriage of the cannon to the airframe, the assembly of the unconventional wings, the careful placement of the high bypass engines, is not just the construction of an airplane. It is the birth of a legend. This is the story of the prototype that would soon be nicknamed the Warthog, an aircraft built for the infantryman, and one that would become the undisputed king of close air support for decades to come.
In 1990, this quiet beach was transformed into a war zone. Saddam Hussein had invaded Kuwait, prompting a coalition of countries to combine forces to expel his army. Iraq had over 500,000 frontline troops with another million in reserve, armed with a formidable array of Soviet weapons, including 5,000 tanks. The USAF had an aircraft in their inventory designed specifically to obliterate Soviet armor and provide the much-needed support for the coalition ground forces, the A-10. Curiously, General Horner, commander of air operations, almost left it behind.
General Horner was called in by General Schwarzkopf before the actual assault launch to review what airplanes were going to be there. 1,900 airplanes to be assigned, 0 A-10s. And Schwarzkopf looks at the list and he says, "Where's my A-10s?" And General Horner says, we have F-16 specially armed. They'll do the job." Schwarzkopf looks at it, says, "I don't want to hear any of your Air Force political bullshit. Give me my A-10s."
The A-10s, aircraft that were at the time 20 years old, managed to outshine the 1,900 aircraft that had been chosen ahead of them, destroying 4,000 tactical targets, a tally higher than all the others combined. With such an impressive performance, why was the USAF so reluctant to bring the Warthog to war? What was it about this tank-busting machine that repulsed them so much? To understand the mystery of the A-10, we have to look back to the origins of the USAF. In World War I and II, the Air Force had been a branch of the U.S. Army. Over time, the role of the Air Force evolved with improved technology and battlefield experience. Aircraft could provide vital aerial intelligence, drop bombs on strategic targets, and move troops and equipment. One of the Air Force's most important jobs was providing close support for troops on the ground. That is, working closely with soldiers on the battlefield and executing the difficult mission of destroying enemy forces without causing casualties to nearby friendlies. As important as this mission was to the overall success of military campaigns, it was despised by many Air Force generals of the day.
From the day one, the United States Air Force going all the way back to the Army Air Corps, there has been this antipathy to the mission called close air support because it is tied to the Army or ground warfare. And it was a mission that did not fit their view of them being able to independently carry out whatever war that they wanted to and not be tied to what was going on the ground, not be tied to another service.
They very early on decided that what they needed to do to get a decent budget was to emphasize that bombing could win wars. That idea, a very false notion, by the way, still runs the Air Force today. They thought they could get much more money if they built bigger and fancier airplanes like bombers, and if they put out a tremendous amount of propaganda that bombers by themselves could win wars.
As much as the Air Force resented and resisted the close support mission, it was a necessary evil. Time and again, bombing alone proved ineffective at breaking the will of the people, whether it was Germany's blitz of Britain or endless bombing raids of the Allies against German targets. Allied ground forces supported by aircraft had the dirty job of taking back Europe mile by mile. Soldiers often found themselves mired in the quicksand of war, the situation shifting from minute to minute. They needed pilots tuned into the chaos of battle.
Infantry working outside the wire on a patrol, they want something above them that can see all, communicate with them, help them with their navigation problems, help them see ahead, and so they won't be surprised. And if they do get surprised and they come in contact, they can get almost immediate fire on the target. By immediate, I mean within a minute.
As much as the Air Force wanted to focus on bombing missions, they still managed to produce some legendary close support aircraft, albeit by blind luck.
The P-47, which was the original Thunderbolt, that airplane turned out to be a close support airplane totally by accident, which is typical of the Air Force. Since the Air Force didn't care to do close support, obviously they weren't going to design airplanes for it. They designed the P-47 as their approach to the greatest thing in the sky, to shoot down Messerschmitts. In fact, it was not the greatest thing in the sky to shoot down Messerschmitts. It racked up a very good combat record in air-to-air combat because it had some, fabulously good pilots, which count far more than airplanes. By pure accident, it turned out it was a wonderful close support machine because it had a huge radial cast iron engine right in front of the pilot, which was like built-in armor for him from the front. Could carry a big load because it was a big airplane, too big to be a good air-to-air fighter. And the engine was very survivable because it didn't have a liquid-cooled engine and radiator. So basically, rifle bullets couldn't bring it down very easily. The P-47 could come home with, 20 or 30 holes in it. And so it racked up a terrific record.
Close support was not considered the most glamorous job, but it was a vital one. The pilots of the 365th Fighter Group, also known as the Hellhawks, flew their P-47 Thunderbolts in one of the most important operations of the war.
It was realized in the Allied headquarters that they needed a tactical air force to support the ground troops directly during the process of the invasion of Normandy. So they needed a dedicated fleet of aircraft, both bombers, transport, and fighters, to seize control of the air and then support the ground troops. So the Hellhawks got drafted, probably not by choice, into that role. They dreamed of themselves as the high-flying pilots with a scarf streaming behind their neck, but they began to realize that they could play a crucial role on the battlefield, and they became very connected emotionally with the GIs on the ground and helping them out.
The Thunderbolt's impact would last long after World War II. The aircraft's success would set the mold for all future close support missions.
The importance of the P-47 and the Hellhawks and the way they use that airplane in combat is still with us today, 65 years later. Since World War II, with a few exceptions in Korea in the early days of that war, American ground troops have never fought without air superiority, without complete confidence that any aircraft they saw overhead was a friendly one. And that's a legacy of the P-47's ability to control the battlefield immediately over the front lines where the fighting was heaviest.
As the war came to the close, a new weapon emerged which changed warfare forever. The dropping of atomic bombs sealed the fate of Japan in World War II. It also seemed to solidify the position of bomber generals who believed that bombing could win wars alone. The U.S. Air Force was in a powerful position, as it was the only service capable of delivering a bomb, albeit one constructed with the Navy's oversight. Though the Army and Navy were not enthused about sharing their budgets with a young competitor and slowed and sabotaged the process wherever they could not stop the inevitable, and on September 18, 1947, an independent United States Air Force was born. Though the Army and Air Force were separate entities, the Army relied on aircraft to operate, to transport troops and equipment, and for the vital mission of close support. In 1947, a document was hammered out between the armed services to divide up the roles and missions of their respective fleets of aircraft.
The Army and the Air Force had negotiated a set of unbelievably bad agreements. I mean, bad for the taxpayer and bad for the soldier, called the Key West Agreements, by which they agreed to divvy up air assets. The Army would be in control of all helicopters, and the Air Force would be in control of all fixed-wing airplanes. And the deal was that the Air Force would not object to the Army getting very large numbers of these, would not object to them, doing armed versions of them, and in return the Air Force promised, we'll give you lots of close support.
A young colonel, Avery Kay, took part in these negotiations. He was a highly decorated and respected officer, having navigated the lead B-17 in the Schweinfurt raids, a treacherous mission to cripple Germany's industrial might. Colonel Kay soon realized that navigating through the politics stemming from the inter-service rivalries was no easier.
He was probably one of the most ethical officers I've ever known, a guy of enormous character and courage, almost to the extent of naivete, being just naive about, about what bureaucratic chicanery is all about. He came to realize within a year or two after having served in these negotiations and written some of this language where the Air Force promised to deliver close support, he realized the Air Force had no intention of ever delivering that support. And out of conscience, he felt personally responsible and guilty that the Air Force had not delivered and that he had personally participated in a lie. And he dedicated the rest of his career to creating a close support airplane that would deliver on the promises that he had been part of.
In just a few years, the USAF's short-sightedness when it came to close support became blatantly obvious. The Korean War was not decided with an atomic bomb blast. It was a grueling conventional war. Here, the USAF pinned their hopes on their speedy new jet fighters. They may have been state-of-the-art, but they were too fast and without the range to be effective close-support aircraft. P-51 Mustangs left over from World War II were taken out of storage and shipped over as a makeshift solution. These aging aircraft suffered heavy losses as their engines were vulnerable to ground fire. The Navy and Marines, with their A-1 Skyraiders and F-4 Corsairs respectively, took the lion's share of the close support work, and they did so brilliantly.
Close support was of the essence, particularly when troops were moving, when we were moving forward, or when the Chinese were pouring over the border and driving us back. The A-1 was in fact a wonderful workhorse, shared the virtues of the T-47, had a big rotary engine up front to protect the pilot, was very hard to shoot down, you could put lots of holes in it, and because it had been designed to pull really big loads off carriers, had a very big wing which allowed it to maneuver very well at low speed. That airplane did brilliant work, particularly in the hands of the Navy squadrons that had it.
The USAF seemed blind to the lessons learned in Korea and oblivious to the idea that there might be another conventional war. In the years that followed, they continued to focus on building nuclear-armed bombers and jets in preparation for an atomic war with the Soviets. The Army realized that they might have to take the close support mission into their own hands. Chuck Myers recalls Army tests he participated in at Fort Rucker.
A lot of guys in the Army, particularly on the aviation side, felt that the Navy and the Air Force were not going to provide them what they needed, which they referred to as organic air support. The only option they had was somehow try to figure out how to do it with helicopters. And that's what was going on at Fort Rucker, was experimenting with helicopters. They were reinventing our old Army Air Corps. My primary helicopter that I was using was an H-13. They had strapped 30 caliber machine guns to the rails.
When hostilities boiled over in a tiny country in Southeast Asia, the USAF once again found themselves unprepared.
Well, what happened in Vietnam is we went into Vietnam in the Air Force, in particular with aircraft that were not suitable for the situations that we encountered.
In the skies, the USAF needed agile dogfighters capable of keeping up with Soviet-made MiGs. Instead, they had aircraft built to drop atomic bombs and fighters that lacked the basic cannon for shooting down opponents at close range. In terms of close support, they were just as ill-equipped as they had been for the Korean campaign. The USAF were forced to use ancient Navy A-1 Skyraiders to take up the slack.
In Vietnam, the great hero of the war was the A-1 again. And the A-1 by that time had been sent to the boneyard. The Navy didn't want to hear about it. And somebody in Special Forces had the sense to see, we need that airplane, and convinced Secretary McNamara to bring A-1s back out of the boneyard, refurbish them.
Not surprisingly, the Air Force were less than enthusiastic about having the Skyraider jammed down their throat by McNamara.
There was nothing that was more hated in the Air Force than to pull out a Navy airplane that had reciprocating engines, no jet, cruised at about 140 miles an hour, right? I mean, this was like anathema to the Air Force.
Though the Skyraiders were an unwelcome gift from the Navy, they proved themselves again, just as they had in Korea.
The A-1 was a very fine bombing platform, and we could get close to the target and be far more active than they could with an F-100 who had to go up, drop his bombs, and get back home quickly before it ran out of fuel.
It saved probably several hundred CIA camps in the jungle that were being overrun, at night by VC and some North Vietnamese regulars.
It would take ultimate damage. Bernie Fisher, who landed during the Battle of Ash Shaw and picked up a lad who had crashed just off the runway. He had, I forget what, 20 or 30 bullet holes through that thing.
While the USAF was trudging forward in Vietnam with the Skyraider, Colonel K, an advocate for close support aircraft, found himself in a new office with a clandestine mission.
Colonel Avery K. He wound up in 1966 in an office, a staff office to the Chief of Staff of the Air Force at the Pentagon headquarters called Concepts and Doctrine. Concepts and Doctrine was a smokescreen. What it really was about was a term of art in the military called roles and missions. What roles and missions means is your job is to defend the Air Force budget against raids by the Army and by the Navy.
At the time, the U.S. Army was in development of a costly new helicopter called the Cheyenne. It was built for the mission that the USAF detested, close support. 50% more than the Air Force's most expensive fighter, the F-4, K recognized that the Cheyenne was a threat to the Air Force's budget. He also saw an opportunity to leverage the situation to fulfill the Air Force's old promise to the Army.
He realized, if the Army does this, if the Army builds this super expensive $4.5 million helicopter, they're going to want 1,000 of them at least. Where's the money going to come from? It's going to come out of the Air Force budget. Perfectly correct perception. He also perceived that this would be a powerful incentive for the Chief of Staff to develop a close support airplane to make sure that the Army didn't get all that money.
K's plan of creating a close support aircraft to thwart the Cheyenne filtered its way up to the Chief of Staff of the time, John P. McConnell. Though McConnell was a bomber general and loathed the close support mission, he had fears about relinquishing it to the Army.
If you let the Army get away with that Cheyenne helicopter, that costs 50% more than our most expensive fighter, that money's going to come out of your hide, and you're going to go down in history as the Chief of Staff who gave up the close support mission. Of course, no Chief of Staff wants to do that. They're all very worried about their legacy. March on, start developing a close support airplane, make sure it's cheaper than the Cheyenne, and make sure it's much more lethal and much more survivable, so that we have a real case that the money should go to our airplane.
Given the green light to create the USAF's first purpose-built close support plane, Colonel K had to build the brain trust that would help shape the aircraft's specifications. At the time, Pierre Sprey was working for Secretary of Defense McNamara, analyzing the USAF's aircraft inventory in Europe.
I've been assigned to do, are we wasting our money on airplanes in Europe? Are we doing the right thing? Are we buying the right fighters to stop 90 or 100 divisions of Soviets from sweeping over Europe? That was the number one threat in the U.S. military strategy at that point. My conclusion was, we are wasting our money. We need to stop buying so many bombing airplanes. At that time it was called interdiction. We need to focus on close support, on actually helping our defending tank troops and anti-armor and so on with airplanes that can do the job right at the point of battle. That made me public enemy number one of the Air Force instantly.
Realizing he had found a like-minded maverick in Pierre Sprey, Colonel K approached him about joining his team.
He says, Mr. Sprey, I've read your paper. I see that you're a big supporter of close support and you think we should be spending lots more money on it. I've been assigned through my boss, and the Chief of Staff has approved, that we start a great close support airplane. He says, I'm stuck because the entire Air Force is sabotaging me. And the rest of them don't want to do it, just the Chief of Staff. And we badly need help. We have no real technical people. Will you help us? There was no way in conscience that I could turn him down. It was such an absolutely correct thing to do and so badly needed. I said, I'll help you in any way I can.
To help Sprey and Colonel K develop the ultimate close support aircraft, they enlisted the help of A-1 pilots fresh out of Vietnam. Their first-hand experience working with the Army would prove invaluable in creating the new aircraft, then simply known as AX. Tom Christie, who helped examine potential contenders for the AX's weaponry, recalls the passion of K's group.
And so I can remember coming up to Washington, TDY, from Eglin Air Force Base, which I did quite often, and meeting with Pierre Sprey, 8 or 9 o'clock at night in the Pentagon, and I'd show up and he'd have 5 or 6 Air Force officers, that were part of this cabal. And the one in particular that I remember was a guy by the name of AVK, and they wanted to make sure that the Air Force did not go wandering off and make the same mistakes they'd made in previous years. They wanted an aircraft that was dedicated to and designed for close air support.
The interesting thing is, you would have imagined that an airplane born in this kind of sin, designed to simply kill an Army helicopter, couldn't possibly become a good airplane. But the interesting thing is, for us down in the trenches trying to shape this airplane, once we had the Chief of Staff's approval, is these were absolutely ideal circumstances for creating a really good airplane at very low cost. I mean, normally you're told, include this technology, you got to include that radar, you got to include this piece of junk, make sure it's plenty expensive so that the contractors get lots of money. Whatever you do, don't make it cheaper than the last airplane. That's what really shapes airplanes today. We had the dead opposite, because our instructions were make the airplane much more lethal, much more obviously lethal than the Cheyenne helicopter, make it much cheaper, and make it much more survivable. That's exactly what you want to do for a close support airplane. So out of the political mayhem of the Pentagon budget battles, we actually had marching instructions that, the designers would kill for.
Pierre Sprey, Tom Christie, and Chuck Myers all pushed for the development of America's first close support plane. In the 1970s, these renegades would bond into a group known as the Fighter Mafia. Together with other like-minded officers and defense analysts, they battled against the establishment to help create the best aircraft to meet the demands of war within the restraints of the government's purse. Though they had their critics, more often than not, the Fighter Mafia were proven to be right. Sprey worked closely with contractors, including Northrop and Fairchild, and reviewed hundreds of designs in the quest to make the ultimate close support plane. But what exactly are the ingredients of such an aircraft?
The primary things you have to be able to maneuver very well at low speed, and that's both to get close to the target so you can distinguish friends from enemies, You can pick up things that the ground guys can't see. And very important, particularly since some of this focus was on Europe, you have to be able to fly under weather. When you've got clouds at 1,000 feet, 500 knot jets become hopeless. You have clouds at 1,000 feet and you have hills that are 500 feet high, and you try to come booming down through those clouds at 500 knots. That's simply not feasible.
The aircraft also needed to be capable of loitering over targets for extended periods, at least 2 and hopefully 4 hours with a full bomb load, 250 miles from base. If a plane had to leave the battle to refuel after just a few short minutes, it wouldn't be around long enough to provide any real support. The A-1 pilots were adamant about this, and about the need for an excellent radio communication system.
You had to have great communications. This was in a day, and by the way, the day extends to today, when essentially no Air Force airplane could talk to the ground. They had radios that deliberately could only talk to other Air Force airplanes or to headquarters or to Air Force radar airplanes, and no direct way to talk to a guy, holding a small tactical radio sitting in a foxhole. My A-1 guys were so insistent on that, they just pounded it into me every day. You can give up anything else, don't give up those radios. That's how important they were.
Another key element of close support aircraft is survivability. Pilots going on such a treacherous mission, close to enemy fire, need to have a reasonable chance of coming back in one piece.
You can't ask pilots to go into an environment this dangerous to airplanes if you can't guarantee them that they're going to, for the most part, get home. And so we put a huge amount of work into survivability.
There was so much attention paid to the aircraft being able to survive in what was forecast to be a very critical environment that we were going to be flying in with a lot of air defenses. In particular, the 23 millimeter gun system that the Soviets allegedly were fielding in great numbers.
You put a 22 rifle into any modern jet, a 22 rifle bullet into any modern jet, and it will penetrate the tank, will very likely create a leak or light a fire, and the leak itself will catch on fire if it's right next to the engine.
Well, a lot of attention, unprecedented attention was paid to that whole concept of reducing the vulnerable areas. Being given a hit, will you go down or not?
A plethora of survivability specifications were laid out for the AX. Using cables rather than flammable hydraulics to control the flaps and other control surfaces, and building the structure of the aircraft the old-fashioned way, with spars covered by skin, a feature that allowed the old A-1s to return home with gaping holes in their wings. But perhaps the greatest feature of the AX was, of all things, a titanium bathtub.
We demanded armor, essentially completely around the pilot, certainly up to this level, from the front, the back, and everywhere, that would stop an American .50 caliber bullet or the Russian equivalent. And that led to a 2,000-pound titanium bathtub. They still call it the bathtub to this day, and the pilots love it because it gives them all kinds of confidence when they're pressing an attack and they're hearing impacts of bullets on the airplane and so on.
As important as survivability was, the AX was an offensive weapon, built to destroy tanks. The whole of the aircraft was designed around a massive gun capable of blowing away the competition. While designing the gun specs, Spray looked for inspiration from a most unusual source, a hero of Nazi Germany. In the 1960s, the U.S. Air Force had a helicopter in their crosshairs. Surprisingly, it did not belong to one of its opponents behind the Iron Curtain, but rather the U.S. Army. The costly Cheyenne helicopter, built by the Army to support its troops, was seen as a potential drain on the Air Force's own projects. To counter this rotorcraft, the Air Force began drawing up the specifications for a new close support plane known as the AX. It was an aircraft and mission the Air Force really didn't want. However, the team at the Pentagon behind the AX saw things differently. They saw supporting troops on the ground as one of the most important missions, and they set about to build what would become one of the Air Force's most lethal weapons. The AX was an offensive weapon, built to destroy tanks, armored personnel carriers, and soldiers entrenched in foxholes or behind sandbags. The whole of the aircraft was to be designed around a massive gun capable of blowing away the competition. While designing the gun specs, defense analyst Pierre Sprey looked for an inspiration from the most unusual source, a hero of Nazi Germany.
Because I was adamant that we had to do this purely from the point of view of the effectiveness demanded by combat experience, I assigned everybody on the team to read a book called Stuka Pilot by Colonel Hans Ulrich Rudel, because I had found nothing in the entire literature on close support that gave a more precise and more objective view of what close support is really about.
Rudel flew an incredible 2,500 missions where he rained havoc on opposing armies, destroying an astonishing number of enemy vehicles, including 519 tanks. His tank-busting aircraft of choice was a specially modified Stuka, armed with two 37mm cannons. Sprey began a worldwide search for a caliber of bullet powerful enough to pierce Soviet tank armor, while not so large as to make it unwieldy for an aircraft to fire. He found the perfect bullet in the land of fine chocolate and watches, Switzerland. Munitions manufacturer Oerlikon produced a devastating 30mm round, which penetrated with Swiss watch-like precision. Now that Sprey had found his bullet, he had to figure out a way to fit 1,000 rounds worth on the AX. The massive amount of ammo was housed in a drum 3/4 the size of a Volkswagen.
Of course, when we started sizing the weapon, see how big it was, a huge ammunition storage, because we wanted enough ammunition for 20 repeated passes. See, that was part of the long loiter, long endurance. It's not just hanging around, you also have to hang around and be dangerous, have weapons.
Carrying so much ammo in such a powerful weapon, the AX might be best described as a flying piece of artillery. Though the 30mm shells were potent and capable of penetrating the thick Soviet armor, they wouldn't necessarily stop a tank in its tracks. At that time, a new type of bullet was in development, which packed a depleted uranium punch.
Depleted uranium has exactly the same properties as magnesium. When you hit with a high velocity, you actually light off the metal. The metal burns inextinguishably, just like magnesium does in a flare. This thing is so incendiary that if you just have grease, the normal grease that's in the sump under the engine, you're very likely to light the tank on fire because there's burning fragments everywhere once you've penetrated.
By 1970, Sprey and his team had put together all the specifications for their AX aircraft into a concept formulation package. The tremendous amount of work they did paid off. The USAF, still eager to kill the Cheyenne helicopter, approved the plans, as did Secretary of Defense McNamara and Congress. The U.S. Army with the Cheyenne and the USAF with the AX weren't the only ones fighting for a piece of the government spending pie. The Marines had a futuristic close-support aircraft of their own, the AV-8 Harrier. Chuck Myers took part in an evaluation of the three designs.
The group leader turned to me and said, well, we need a plan. Who are we going to visit? Who are we going to talk to about this subject? And I said, well, I think we probably ought to start with the Marine Corps because they probably know more about the subject than anybody else. They have great interest in air support. I set up the meetings for them over at Marine Corps headquarters, and our little group went over there. And we spent a whole morning listening to Marine Corps expound on the subject. And of course, they were pushing this thing called a Harrier, which, if I could think of an airplane least appropriate for close air support, that would be it, because of its vulnerability to small arms fire.
Myers soon realized the bomber generals in the USAF weren't the only ones who had antipathy for the close support mission.
We all convened for lunch, and it broke up into little groups. And I remember sitting at a round table having lunch with a couple of Marines, and one of them was a colonel. And I never forget the colonel saying, he thumped the table and said, boy, we can hardly wait to get our F-14s. And the other guys in my group looked at me like, they're F-14s. They were no more interested in close air support. All they could think of was they were going to get the F-14 along with the Navy. Everybody wants to fly fighters. Nobody really wants to do this horseshit mission down there in the dirt.
While Congress evaluated the aircraft available for the close support mission, Spray's paper airplanes were turned into prototypes. When it came to testing, Spray once again carved his own path.
I had felt very strongly all along that the right way to do this was to get prototypes built, 2 or 3 prototypes by each company, and have a real firing shoot-off, a competition, a fly-off.
The A-9, A-10 were the 2 entries into the AX program, which was our first foray into a fly-off. That was a different approach. The 4 aircraft, 2 from each company, were flown over a period of many months at Edwards Air Force Base.
That had never been done in the Air Force before. They built lots of prototypes, and people were very reminiscent and very nostalgic about how great it was when we built one, but they never flew against each other. They were kind of engineering models. They went to Edwards Air Force Base. The test pilots flew them, clocked how fast they flew, how long, how high, how fast, and then kind of on paper compared them to other airplanes. We didn't want that. We wanted a real competition where you went and did the mission as realistically as you could with 2 manufacturers fighting it out, and the guy who did the mission best would win.
Northrop and Fairchild Republic were given a little over a year to construct 3 prototypes each, 2 flying and 1 in pieces just for test fire experiments. The possibility of being struck by ground fire was a reality of the close support mission, something not factored into the designs of most jets of the era, which made them vulnerable to attack. Spray challenged aircraft manufacturers Northrop and Fairchild to design planes which kept the volatile fuel supply and the hot-burning engines as far away from each other as possible. While Northrop buried the engines next to the fuselage, Fairchild came up with their own innovative solution.
Fairchild came up with a superb solution. They have the engines out on pylons away from the fuselage. There's no fuel between the engines. All the fuel is way forward in the wings, and it's brought a lot of pilots home. There would have been in airplanes that were burning and crashing.
Spray once again rattled the establishment, this time with his choice of test pilots.
We had the shoot-off at Edwards Air Force Base. Half the pilots were test pilots. This was another huge battle. Half of them were fighter pilots, real pilots, which was crucial because we were going to do so much bombing and strafing. That's not something that test pilots, are particularly adept at. That was another revolution, another bureaucratic mess. Because, of course, the test pilot community has their own little sacred cows.
So these 2 airplanes were flown first by company pilots and then turned over to a team from the Air Force to go through a whole procedure in flight and in other logistics analyses, the whole roll of wax.
It was an extremely close competition between Northrop's A-9 and Fairchild's A-10. It was hard to choose a winner before counting up all the bullet holes and tallying up the scores on each test.
I had thought that Northrop was going to win because they had a somewhat slicker design, a little better aerodynamics. And lo and behold, after all the shooting was done and all the testing, Fairchild had taken the survivability a little more seriously, had an edge there, had a slight edge on some of the accuracy, dive bombing accuracy stuff, and they were awarded the contract. It's exactly what's supposed to happen. The guy you didn't think was going to win won because he did a little better. It was pretty close, though. It was a really tight race. We wouldn't have been badly served by either airplane.
The A-10 Thunderbolt II was named after another legendary close support aircraft, the P-47 Thunderbolt. The A-10 was an excellent design, but Fairchild still had to work out some serious technical issues.
We were doing all the follow-on tests on the A-10, primarily gunfire. because when you were firing guns, the engines would quit. And when the engine would quit, it would be very quiet. I mean, you didn't hear, it wasn't like a compressor stall where it makes a lot of noise. It would just, the temperatures would go up on the engines and ruin them, or the RPM would come down. So I flew thousands and thousands of rounds at the ground to try to solve this engine problem. The problem with the A-10 with the engines were twofold. One, with the gun gas going in the engines and causing the engine to quit. The other one was pulling high angle attack or high turn rates, because the airplane had good handling quality, so nothing bad happened aerodynamically. But the engines couldn't stand the lack of the air. So the solution to both problems was to put continuous ignition on the trigger. So anytime you fired that, the continuous ignition came on to both engines. So if it quit, it restarted immediately. And also high angle attack, on angle attack. So ignition comes on at high angle attack. The engines keep running. Well, they don't keep running, but the pilot doesn't know the difference.
With the A-10 selected for production, the Air Force found itself in an unpleasant situation. Their motive for supporting the A-10 was always to kill the Army's Cheyenne. In 1972, that became a reality. With the Cheyenne dead, they suddenly had a new close support plane in their hands, an aircraft they really didn't want for a mission they despised.
1972, the Cheyenne was safely dead. It had been killed. The Air Force had accomplished its mission, and now started an unending series of assaults to kill the A-10. There wasn't a month that went by that some general didn't have some idea about how to kill the A-10.
The Air Force felt the A-10 was primarily supporting the Army, and they really didn't make that mission. In fact, at one point in time, they were talking about giving the A-10s to the Army. But then the Air Force decided that was their mission, is to fly airplanes and not the Army's mission. So that got to be controversial. So the Air Force said, okay, we'll support the Army.
Air Force generals got together with an airplane manufacturer in Texas, Ling Technical Vought, the old Chance Vought company that had been building A-7s for Vietnam. A pretty poor bombing airplane, highly vulnerable, full of flammable hydraulics and all that. And they claimed that they had a model that would do close support superbly. They got some congressmen to back them, along with these Air Force generals, and they actually forced us to do a fly-off of the A-7 against the then still in development A-10. So we dragged out the YA-10, the prototype, and had a little fly-off. The A-7 was so laughably worse that nobody could pretend that this was a good excuse for killing the A-10.
The A-10 seemed to be equally resistant to battle damage as it was from assaults from the Air Force. Production continued, and in March of 1976, the 355th Tactical Training Wing, based at Davis-Monthan Air Force Base, Arizona, became the first unit to receive the A-10 Thunderbolt II. This did not dissuade the Air Force from continuing to do all it could to whittle production numbers.
Interestingly enough, the Reagan administration comes in, and as I recall, the A-10, we had a procurement goal of 733 airplanes, something like that total. We had one more year to go. And the Reagan administration rolls in and, of course, throws money at everything the services wanted. And then Stockman, recall Mr. Stockman, who was OMB at the time, sort of said, my God, we need to take a look at all this money we're spending. You know, we're going in the whole tax cuts and all that. So he took aim on the defense budget.
Stockman, the director of the Office of Management and Budget, battled with Secretary of Defense Caspar Weinberger over Reagan's bloated defense budget. A compromise was reached, which would leave A-10 production in the crosshairs.
Weinberger came back and said, hey, we got to show that we're stewards of the budget, so we need to cut some things. Lo and behold, what does the Air Force offer up? The last year of A-10 production, I think it was a smaller number. We had been up to, I think, 144 aircraft a year. And they also tried to cancel the ammo procurement. Unbelievable. They didn't get away with that.
It wasn't just the Air Force brass who had misgivings about the A-10. Pilots of the day would have preferred to be flying the latest supersonic fighters, but it didn't take long for them to come around.
The guys who joined the A-10 community for one reason or another, a lot of them were there as punishment tours because it wasn't a glamorous tour for anybody. But they became committed to the airplane. The more they learned about the airplane, the mission, what it takes to help guys on the ground, how demanding the mission is, because it takes an enormous order of skill. I mean, it takes a whole set of skills air-to-air pilots don't even dream of. It's a totally different world. And they became dedicated to that world. And then, actually, you know, a bunch of wars came along where they could actually exercise those skills and refine them. And what's interesting is they had the same opposition from the Air Force in the wars as we had when we were trying to produce the airplane.
The A-10's first combat mission was the invasion of Panama in 1989, when the U.S. ousted Panamanian dictator Manuel Noriega. Though the aircraft faced no real resistance, it would soon have an opportunity to prove itself fully. On August 2, 1990, Saddam Hussein invaded Kuwait. There was international condemnation of the event, and the Iraqi dictator was given a hard deadline of January 15, 1991 to withdraw his army. Coalition forces built an impressive armada of weapons to push Hussein out of Kuwait, including 1,900 aircraft. Curiously, General Horner, commander of air operations, almost left the A-10 behind.
General Horner was called in by General Schwarzkopf before the actual assault launch, and Schwarzkopf looks at the list and he says, "Where's my A-10s?" And General Horner says, we have F-16s specially armed. They'll do the job." Schwarzkopf looks at it, says, "I don't want to hear any of your Air Force political bullshit. Give me my A-10s."
General Schwarzkopf recognized the abilities of the A-10 as a tank buster and close support plane. It had been built to destroy Soviet tanks, and the Iraqis had more than 5,000 of them. He made a wise choice. The A-10 destroyed more tactical targets than all other aircraft combined. Even General Horner could not deny the A-10's excellence, at least temporarily.
The A-10s did such a good job of bailing out the failures of other airplanes that the same General Horner who had refused to deliver A-10s at the beginning of the war said, right in the middle of his staff in the famous black hole bunker in Saudi Arabia that was commanding the whole air war, after he saw the results of the A-10s, particularly even in wiping out missile sites, mind you, which they'd never been intended to do, he said, "I take back every bad thing I said about the A-10. They saved our asses." And that was heard by a whole bunch of staff members, has been widely quoted since then. Now here's the interesting thing. After the war, when everything had died down, people had done the battle damage assessment, and by the way, the Air Force had totally suppressed the successes of the A-10 that I just quoted, and had put out a whole bunch of junk about how brilliantly the F-117 did and all that. It was all hogwash. General Horner was forced by his fellow generals to renege on what he had said and join the assaults on the A-10. You know, actually went back on what he had said about how they saved our asses. He said, no, they weren't that important. Now you ask yourself, how could a guy who had spent his career, you know, flying airplanes, he'd flown a lot of fighters, he wasn't just a bomber guy, but once he got to be a general, he was so infected by the culture around him of the other general officers, and that culture, dating again back to the 1920s, was a bomber culture. It's, you know, we bomb targets that we assign to our Air Force. We do it independently of the Army. We do it with airplanes that are very expensive because they're good for getting us a bigger budget. And that's what the Air Force is about.
Though the A-10 had done excellent work against Iraqi forces, by the end of the first Gulf War, the Air Force should have had a replacement in the pipeline. Aircraft have long gestation periods, and the A-10 was based on 1970s technology. But the bomber culture that permeated the upper echelons of the Air Force made a new aircraft nearly impossible.
A lot of the people in the close support community, the military reform community, in 1983 started proposing developing a far better, far more modern A-10. We called it variously the Mud Fighter or the Blitz Fighter. And it was going to be smaller, hotter, much better maneuverability, better able to get close in, better able to survive, have even more lethal weapons than the A-10, and we were ambitious to make it even cheaper than the A-10. And we had designs laid out, and we briefed them all over the Pentagon, and the Air Force came down like one man to kill it.
The Air Force went bonkers. When they found out that Lockheed at Marietta, there were people down there doing some work on that, they told Lockheed, either you back off this and stop all this, or you don't have a prayer's chance of competing with what was coming down the road, which was the Advanced Tactical Fighter, which became the F-22. So they stopped.
To put the final nail in this new aircraft's coffin, the Air Force offered a compromise of sorts.
An Air Force two-star came down and said, okay, we want to sign a peace treaty. You guys back off pushing this new aircraft, okay? You do that, and we promise we will back off retiring A-10s. Not only that, we will upgrade them. So we agreed. So they did. They took away the planned retirement, which was to start probably in 1990-91.
Without a replacement, close support pilots were forced to soldier on with aging A-10s. Now the Air Force had a new excuse to rid themselves of the A-10. It was too old.
Nothing changes about these assaults. The first one is always, the airplane is so old. It's aging, it's decrepit, it's going to cost a lot to maintain. It's a perfectly silly argument. First of all, the A-10 is not the only old airplane in the Air Force. The Air Force generals are defending a far older airplane, the B-52. It's okay, we've so refurbished it and remodernized it, even if it is older than all the pilots, who cares? Well, oddly enough, the same thing is true of the A-10. The A-10 had been heavily refurbished. In fact, it's an amazingly modern airplane now. First of all, most of the fleet has been re-winged, although the Air Force is now trying to steal that money for the F-35, the re-winging money. But most of them have already been re-winged and will be good to 2040. Secondly, it's completely false that older airplanes get more expensive to maintain. The older airplanes, B-52 included, are vastly cheaper to maintain than any of the new airplanes that replace them. And they're just like old cars. If you find somebody to make the parts, you can keep a car going forever, and people who love the car do.
As the airplane stands today, there's nothing that can touch it in terms of performing this mission. There's just no way. It can do all the things that the ultra high-tech systems can, like F-15s and F-18s and so on. It can do all those things just as well as they can, but it can work the other end of the spectrum down low. In lack of anything else, I would open the line and build more A-10s.
From the invasion of Iraq to Afghanistan to the war against ISIS, the Air Force has been equally reluctant to bring the raging warrior to battle with them. Though the A-10s took part in the initial assault on Iraq, they were mothballed from 2003 to 2007. The USAF tried to rely on F-16s and other fighters to hit targets on the ground, but they were often inaccurate and caused casualties amongst friendlies. It wasn't until 2007 that the Air Force was forced to concede they still needed the A-10, an aircraft originally designed for a jungle war.
The A-10 was a Vietnam follow-on because all the airplanes in Vietnam didn't have much fuel to stay around the target area. And of course, Vietnam was over, but it turns out now that the A-10 was perfect for Iraq and Afghanistan because it can loiter for long times. It's got plenty of ammo. That gun is absolutely outstanding as far as the 30 millimeter. You put the pipper on the target and the first dozen bullets go there. No question. That's where they go.
Like the USAF, the Russian Air Force has a dedicated ground support aircraft of their own, the Sukhoi Su-25, an aircraft with an uncanny resemblance to Northrop's A-9. Introduced in 1981, it is still in production, and with multiple upgrades it continues to support Russian troops and the troops of buyers from around the world. The Russian Air Force does not seem to have the same hangups about close support as the USAF, and in 2015, the Su-25 was brought into Syria to combat ISIS. Rather than create a new dedicated close support aircraft, the USAF is pinning their hopes in dollars on stealth multi-role fighter, the F-35. This versatile aircraft was designed to handle the missions of not only the A-10, but also the F-16 and F-18 and Aviate for the USAF, Navy, and Marines. Critics of the A-10 label it a single-purpose aircraft, but could a jack-of-all-trades master any of these missions?
Here we are now with the A-10, obviously now 40 years old, 30 to 40 years old, though it's still got life. And we have one program going, F-35, and that's going to fill all these missions. And that's just outrageous to even, think about that.
Multitasking is a huge waste of money because it leads to enormously expensive airplanes. Instead of that $250 million airplane, we could have a great close support airplane for $20 million or $25 million. We could have a great fighter, air-to-air fighter, for $30 or $35 million. And then we could have whatever else you need, a reconnaissance airplane or those other kind of missions that maybe it does. We could have one of those for $30 or $35 million.
It's uncertain when the F-35 will be able to take over for the A-10 and how effective it will be. Though the A-10s have been upgraded into the most advanced close support aircraft in the world, the USAF is almost embarrassed to bring them to front lines as they battle ISIS and prepare for a potential conflict in the Ukraine.
I agree with the Air Force, It is a disgrace that we're flying that ancient airplane, and it's their fault. Because we should have been started, by the mid-'80s, we should have been started prototyping something that was better than the A-10, and then let it prove that it was better. If it wasn't better, then we wouldn't build it. So we never did that, because the Air Force never wanted to do that mission.
Over the years, the A-10 has proven itself the premier close support aircraft in the world. Sadly, it has also become a symbol of the strife between the branches of the armed services. The A-10 was authorized by the Air Force as a means to destroy an Army helicopter. Though it ended up doing an exceptional job supporting the Army, from day one it has been under attack from within. The A-10 still has its detractors, but the resilient aircraft is ready to prove itself if given the chance. As each branch fights for its share of the defense budget, perhaps they are blinded to the bigger picture, that they are at war with their enemies, not each other.
Compared to the vastness of the world's oceans, a modern aircraft carrier is just a tiny speck, necessitating the use of advanced spy planes and satellites to monitor its location. In reality, each of America's 14 carriers delivers a powerful impact, with the most impressive collection of offensive and defensive aerial weaponry ever deployed at sea. The United States Navy's Carrier Air Wing, featuring the F-14 Tomcat, plays a crucial role in this story. From the initial design sketches to the first operational systems and carrier landings, a modern aircraft carrier is arguably the most well-organized and efficient military system ever created. Aircraft make the carrier viable, but it's the pilots who bring it to life. Tailhook pilots believe they're the best, and who could argue with them? However, they're only as good as the support crew, the technicians who maintain the weapons systems, the mechanics who oversee the engines, the plane captains who ensure they're ready for flight, the handling officer who positions them on the deck, and the air boss who directs their movements. It's a unique community, dedicated people putting their skills on the line every day. The F-14 Tomcat, developed by Grumman Aerospace Corporation, is the result of a significant disagreement in 1964 involving the US Navy, then Secretary of Defense Robert McNamara, General Dynamics, Grumman, and the US Congress. This intense bickering stemmed from a well-intentioned decision by McNamara in 1962 to develop a multi-service tactical combat aircraft with a basic airframe common to both the Navy and the Air Force.
That is your bogey.
This led to the creation of the General Dynamics Grumman F-111AB, codenamed TFX, which was extraordinarily versatile but undoubtedly overburdened. McNamara argued that a fighter with high airframe commonality between the Air Force and the Navy would save taxpayers millions of dollars. However, as a technologically precedent-setting program of unparalleled proportions, the F-111 encountered several serious issues during its preliminary flight tests. Chief among these was a significant weight problem, almost entirely due to the basic specifications, which ultimately became the F-111's Achilles heel. It was perhaps the most single important factor leading to the airplane's premature demise. Not surprisingly, the Navy was not displeased with this decision. In fact, a year earlier, they had quietly begun reviewing an internal Grumman study advocating for a completely new all-Navy fighter aircraft. Almost as soon as Grumman was released from its obligations to the F-111B, the Navy issued a request for proposals for the VFX, the aircraft Grumman had already been developing. Grumman was well versed in building aircraft for the Navy, from the Cat fighters of World War II to the F-9F Panther in Korea, the Navy's first jet fighter to see combat. The F-10F Jaguar, a cat ahead of its time, was the first fighter with a variable sweep wing, a concept that proved valuable 25 years later. In between, Grumman designed and built the F-11 Tiger, a longtime favorite of the Navy's Blue Angels, and the Super Tiger, a Mach 2 version that set a world altitude record. With a strong pedigree and design already underway, it was no surprise when Grumman was awarded the VFX contract in January 1969. From that point, work progressed at a breakneck pace. Although 6 years had passed since the TFX program had been approved, the Navy was no closer to obtaining its new fighter. The timeline allowed only 2 years to get the VFX, now known as the F-14 Tomcat, into the air. The same basic engines, Pratt & Whitney TF-30 turbofans, were used. However, these power plants turned out to be the major technical problem for the Tomcat in service. Thousands of design configurations were narrowed down to 8 and then to just 1. In some respects, it wasn't significantly different from the abandoned F-111B. Confident in its abilities and certain that its design would be chosen, Grumman began preparing long lead time materials well before the VFX contract was awarded. The same Hughes AWG-9 radar fire control system was installed, and the design included 2 crew members seated one behind the other, unlike the side-by-side arrangement in the TFX. However, these similarities were only internal. Externally, the design was entirely different. As the VFX mock-up revealed, nothing quite like the Tomcat had ever been seen before. Instead of using a conventional fuselage that integrates crew stations, avionics, engines, and fuel with attached flying surfaces and pylons for weapons, Grumman appeared to start with a giant aerodynamic lifting body. The outer sections of this body were pivoted for variable sweep. Beneath this structure, set far apart, were 2 long engine nacelles with intake ducts extending well forward. With no traditional fuselage, the radar gear and crew stations were housed in a nacelle added to the front of the lifting surface and seamlessly integrated. Although it appeared to be a patchwork of different elements, the entire design blended together remarkably smoothly, maximizing lifting potential while minimizing weight. Many details were modified, but the most noticeable change was in the vertical stabilizer. The Navy wasn't fond of the central fin arrangement, but due to carrier stowage constraints, they could not compensate by increasing the height of the main tail fin. Instead, twin dorsal stabilizers were adopted, giving them a cranked gull appearance when viewed from the front. The front nacelle was resized to improve cockpit visibility for the crew. With the contract secured, Grumman began preparing in earnest for the production of 6 prototype pre-production aircraft and 463 production aircraft. The first flight was scheduled to take place by January 1971, only 2 years away. The first F-14 prototype was rolled out at Calverton, New York, on the 14th of December 1970, and a week later it flew for the first time. Despite the urgency of the program, it was possible to tweak the design as the first few aircraft were being assembled. Most of these changes were cosmetic. As usual, Grumman had got it pretty well right the first time. However, the Tomcat's second flight on December the 30th ended in disaster when the hydraulics failed. The crew ejected safely, and the accident proved to be only a minor setback. By May 1971, the second Tomcat was airborne. However, by this time, political problems were beginning to loom. The VFX contract, negotiated between Grumman and the Navy, was a comprehensive procurement package, allowing for a 2 to 3% annual inflation index. All 469 aircraft were to be delivered within this agreement, divided into 8 batches over a decade or more. However, as is now well known, the index proved to be hopelessly inadequate, especially as inflation soared from around 1970 onwards, causing increasing anxieties. This situation was exacerbated by the reduction of the total number of Tomcats to be purchased to 313, significantly driving up the unit cost of each aircraft. Flight testing, involving approximately 20 aircraft, continued through 1971 and 1972. The first supersonic sortie was conducted on September 16, 1971, by the 12th aircraft, which had taken over the duties of the first prototype. The trials were rigorous and involved an unusually large number of aircraft to meet the deadline for delivering the Tomcat to operational squadrons. Navy preliminary evaluations commenced toward the end of 1971, subjecting the aircraft to simulated carrier approaches, maneuvering them around flight decks, lowering them down carrier lifts, navigating around hangars to assess their compatibility with the large ships that will become their home, and conducting shipboard catapult takeoffs and arrested landings. Testing of the complex weapons systems of the F-14 began the following year at Point Mugu, with particular focus on the AIM-54 Phoenix missile, the aircraft's major feature. The results were remarkable. Drones, modified to simulate various Soviet aircraft, were intercepted with exceptional success, achieving unheard-of ranges. In one spectacular trial, for example, a drone doing Mach 1.5 at 50,000 feet was on the receiving end of a Phoenix launched 120 miles away. In another test, a ripple salvo of AIM-54s, spread across about half a minute, successfully intercepted 4 targets at ranges varying between 30 and 50 miles. By June 1972, carrier trials aboard the USS Forrestal had been successfully completed, indicating that the aircraft was ready for operational deployment. Subsequently, in October 1973, VF-1 and VF-2, serving aboard the USS Enterprise, began receiving their first aircraft from Replacement Training Squadron VF-124 at Naval Air Station Miramar near San Diego, California. VF-1 became the first operational squadron to qualify the F-14A for daytime carrier operations in March 1974. By the end of 1979, the Tomcat had been deployed operationally with a total of 14 squadrons. Additionally, it equipped 2 permanently shore-based training units, VF-101 at Oceana and VF-124 at Miramar, respectively supporting the Atlantic and Pacific fleets. The process of replacing the F-4 continued until well into the 1980s, ultimately resulting in an additional 8 frontline squadrons receiving the F-14A. This aircraft has also been issued to second-line echelons of the Naval Air Reserve Force, a process initiated during the autumn of 1984 when VF-301 at Miramar received its first Tomcat. What sets the F-14 apart from all other tactical aircraft flying today is the combination of a high-performance airframe and the multi-shot, multi-target AWG-9 Phoenix weapon control system, marking the most significant advancement in weapon system technology in a generation of fighter development. Virtually impervious to electronic countermeasures, the Phoenix missile is specifically engineered to eliminate multiple maneuvering high-speed targets from extremely long ranges to close in, making it the only air-to-air radar missile with a launch and leave mode. The Phoenix has proven its performance time and time again against a variety of targets in a variety of tactical situations, scoring an unprecedented 85% success rate. Unlike any other system, the F-14 can fire up to 6 Phoenix missiles at 6 different targets simultaneously, while also tracking up to 24 targets simultaneously. In contrast, other new fighters are limited to engaging one target at a time.
Once the pilot or the pilot has determined they're going to attack a target, they are stuck with that target. They can't see anything else.
So he has to stay in search. He's back to a manual system, the same thing that the F-4 came out with 15 years ago.
This is the only system we've got going where you can attack a target and not have to devote your full attention to that target for the full time of flight of the missile, whatever you're firing. We can prepare ourselves to take on the rest of the threat. It's one-of-a-kind thing.
The F-14 has the long-range Phoenix missile, which gives us approximately twice the range of any other missile that we know in existence today.
However, regardless of sophistication, no weapon system can be effective unless there's sufficient time to deploy it, which requires early detection. The F-14 is equipped with a high-powered radar and an extremely fast digital computer, providing almost 3 times the detection volume of current fighters at 30 to 50% greater ranges. This extended range translates to more time to respond, offering up to 2 extra minutes for a Phoenix missile to intercept a Mach 2 threat. This difference could be crucial in determining the outcome of a mission. It also gives the pilot the ability to stand off and fire a Phoenix missile before being detected or before the enemy can fire, since he has to get a lot closer to fire.
Because we get to see him first, we're going to get a cut right there. We're going to get the edge right there. Here we are standing off, having the standoff capability to fire and attack a target when we have come nowhere close to him being able to do that to us. Okay, what happens then? Your survivability goes up tremendously. You take one aircraft and he can do the job of 5, 6, 7, 8, a dozen aircraft.
Let's face it, if you can get a guy at 100 to 150 miles, that's where you want to get him. You don't want to wait till you have to get him in close.
The third version of the Phoenix missile, designated AIM-54C, offers greater reliability, enhanced resistance to electronic countermeasures, and improved overall performance to effectively address anticipated threats in the 1990s. Meanwhile, cruise missiles have advanced the art of low-altitude flying, presenting a new challenge to air defense systems. Launched from air, surface, and undersea platforms, these self-guided weapons pose a significant threat. Within the realm of modern technology, only long-range airborne radar can detect these low-flying threats in time to protect land targets and surface traffic. The F-14 is the only aircraft equipped to intercept such threats, illustrating its versatility.
The capability to look down and shoot down most effectively. Very good probability of kill.
It goes past that because it gives you the capability to stay at high altitudes. And if you can stay up there, you not only then have the capability of attacking the low guy, now I also have the capability of going after the high guy.
This highlights the dual capability of the F-14, from defending against targets flying as low as 50 feet above the surface to intercepting high-altitude, high-speed aircraft and air-to-surface missiles at altitudes of 70,000 to 80,000 feet.
There's only one aircraft in the world today that has that capability, and that's the F-14 with the Phoenix missile.
In addition to the Phoenix, the Tomcat also carries the AIM-7 Sparrow and the AIM-9 Sidewinder missiles, both of which have undergone recent improvements. The Sparrow's modernized version, the AIM-7M, began production in 1982 and will eventually be replaced by the Hughes AIM-120. The AMRAAM possesses a significant advantage in being a fire-and-forget missile, unlike the Sparrow, which requires continuous illumination of the target by the launching fighter until impact. Despite being one of the oldest missiles in the US inventory, the infrared homing AIM-9 Sidewinder remains a highly effective weapon, demonstrating impressive kill rates in recent years. The principal version used by the Tomcat is the AIM-9L, which was notably employed by VF-41 with remarkable success during its engagement over the Gulf of Sidra. This version represents a significant improvement over earlier models, boasting all-aspect capability, allowing it to home in on aircraft skin friction from any direction. A new iteration, the AIM-9M, has been introduced, featuring an improved rocket motor and enhanced anti-countermeasures capability, and is now also in service. The Sidewinder missile is poised to remain an important component of the Tomcat's armament for many years to come. An internal gun mounted low in the port side of the nose and equipped with 675 rounds of 20mm ammunition can be fired at a rate of 100 rounds per second.
It's almost a self-contained GCI interceptor fighter combination that can take the fight to any scenario, any place in the world.
I deployed with VF-1 and 2 on the Enterprise, and we used to simulate very realistic scenarios. For example, backfire bombers flying at 50 to 55,000 feet at supersonic airspeeds with lower fighter cover. We went out on exercise after exercise like this with the F-14 and demonstrated time and again that because of the two men in the airplane, because of our ability to handle the ECM problem, we could shoot those bombers at long range, still have the short-range weapons to get in and visually engage the fighters, take care of them, and press on about our business.
In today's era of automation, there's a tendency to rely heavily on computer systems for managing tasks. Undoubtedly, computers have enabled us to overcome challenges that would have been insurmountable otherwise. However, we're also aware of their limitations. Despite the F-14 being highly automated, with a computer system capable of processing 3 times as much information as any other fighter, it still operates with a 2-man crew. This setup allows them to fully exploit the aircraft's vast potential by working together.
There has to be tactical decisions made by an aircrew. It cannot be done by a black box. It has to be made in the human element involved.
The advantage of not having to split yourself down the middle or whatever percentage you got when you're in a tactical environment.
With 2 guys working on the solution, you're going to come out with the right answer more often than you are with 1. That's all there is to it. It's that simple.
It's a beautiful combination. And I know in my past experience, there's the first guy to see the other guy has a hell of an advantage.
Given the substantial amount of information exchanged between the F-14 and the command center, voice communication often proves inadequate, too slow, or strategically undesirable. To address this, the aircraft's data link system plays a crucial role, facilitating the rapid exchange of tactical information and receiving additional target data from the command center.
Roger. And Dick, you're cleared to fire.
102, your bogey.
Even when facing an enemy dispersed over a 200-mile radius at various altitudes, the F-14 can be strategically positioned for optimal tactical effectiveness. It stands alone as the only aircraft capable of downing 4 adversaries and still having ample fuel reserves for extended combat engagements.
The nice part about the F-14 is that you got the best of both worlds. You can get into the dogfight role without taking one iota away from the very significant capabilities in the long-range interceptor role.
Wing buys an awful lot. It gives you an awfully good on-station loiter time. It gives you a tremendous turning aircraft, and it gives you a slow approach speed.
Throughout the flight regime, and almost at any store loading you'd care to dream up, you decide where you want to go and you point the nose and the airplane goes there.
It's going to be an awful long time before anyone could come close to finding an aircraft that can take the interceptor role and the fighter role and come any closer to optimizing the two in one aircraft.
The nice part about the whole system is that being computer-based, software-oriented, the growth potential in the system is almost unlimited.
A new television camera system, now operational, allows visual identification at distances far beyond the capabilities of the human eye. This system comprises a closed-circuit television setup with a gimbal-mounted stabilized camera, providing a wide field of view for target acquisition. The radar intercept officer can then switch to a close-up mode for precise identification. Additionally, the introduction of TARPS, the Tactical Air Reconnaissance Pod System, has expanded the Tomcat's mission capabilities significantly. Mounted on the rear left Phoenix station, the forward section of the pod contains a frame camera able to produce forward, oblique, or vertical imagery. The TARPS system includes a panoramic camera for horizon-to-horizon coverage, along with an infrared line scanner. Carrying a TARPS pod only marginally degrades the F-14's performance. Despite more than 17 years passing since the Tomcat's first deployment aboard the USS Enterprise, little has changed in subsequent production models. The Tomcats currently being manufactured are essentially identical to those produced during the 1970s at the Calverton production line. This consistency underscores the robust design of the aircraft and its associated AWG-9 weapon system. However, the F-14A has encountered its share of challenges, particularly regarding the TF-30 power plant. Improvement initiatives aimed at the Pratt & Whitney power plant did not fully address some of its shortcomings. The engine remained susceptible to compressor stall and required meticulous handling during air combat maneuvers. Initially, it was planned that the TF-30 would serve as an interim power plant for the F-14A, with production transitioning to an F-14B variant equipped with a definitive engine. In the early 1970s, there was consideration for using a version of the Pratt & Whitney F-100 turbofan known as the F-401 for this purpose. An F-14B prototype did indeed emerge during this period. The F-14B prototype made its maiden flight on September 12, 1973, accumulating a modest total of 33 hours between then and April 1974. This test program was described as reasonably successful, but this was accomplished against a background of financial difficulty, which at one time looked like what had seriously threatened the future of both Grumman and the Tomcat. As expected, the majority of resources were allocated to the continued production of the F-14A, resulting in the F-14B being relegated to limbo despite showing promise. Another variant, the F-14C, which would have introduced new, more advanced electronics, also fell victim to budget constraints, leaving the F-14A as the definitive production model. It wasn't until the latter half of the 1970s that serious consideration was given to re-engineering the Tomcat. The re-engined Tomcat, known as the Super Tomcat, took its inaugural flight from Calverton on July 14, 1981, embarking on a modest series of development flights totaling 30 sorties. These tests revealed significant performance enhancements in almost every aspect. Consequently, in October 1982, a decision was made to proceed with full-scale engine development, resulting in the F-110. Notably, loiter time during combat air patrol missions increased by 34%, while the deck-launched intercept radius at Mach 1.3 saw a remarkable 62% improvement, extending to approximately 275 nautical miles. The greatly increased power output also permitted catapult launchers to be made dry without afterburner, a factor which must have greatly impressed the Navy, since some of the earlier accidents had arisen from compressor stall when employing afterburner during launch. The F-110 engine demonstrated remarkable resistance to compressor stall across the flight envelope, allowing for unrestricted power management, a feat impossible to achieve with the TF-30. Despite these impressive results, it will be a couple of years before the Navy decided to adopt this new power plant. The US Air Force took the initiative, ordering the F-110 into production for the F-15 Eagle and the F-16 Fighting Falcon in February 1984. Subsequently, the Navy followed suit, selecting the F-110 to power a new Tomcat model designated the F-14D. While originally intended for installation on the F-14D, the F-110 made its fleet debut in the F-14A+, which was delivered to operational Tomcat squadrons in the spring of 1988. Future Tomcat pilots undergoing undergraduate jet flight training will embark on their first carrier experience aboard the new McDonnell Douglas T-45 Goshawk. This aircraft is a modified version of the British aerospace-built Hawk, adapted for aircraft carrier operations with reinforced landing gear, an arresting hook, and catapult launch fittings. As for the historical context, during the first 5 months of 1968, the United States Navy experienced a MiG kill ratio of less than 3-to-1 in aerial operations over Southeast Asia. The small MiG aircraft engaged both Navy and Air Force fighters in classic close-in dogfights, often outmaneuvering US pilots. The differences in maneuverability, design, and size between US and MiG series aircraft, coupled with the absence of a dissimilar aircraft training program, were identified as major factors contributing to the Navy's low kill ratio. In response to the MiG threat, the Navy established the Fighter Weapons School, known to most as Top Gun. It was a provisional but provocative measure to rapidly train fighter crews for aerial warfare. Top Gun initiated an intensive program focused on teaching threat capabilities and advanced air combat tactics, which were practiced against dissimilar aircraft. The impact of this initiative was quickly evident. Prior to Top Gun training, pilots with limited combat experience were being pitted against seasoned North Vietnamese flyers and struggled to maintain parity.
Airfield, this is Victory 5, Grand Slam 1 bogey.
However, after completing Top Gun training, graduates returned to Southeast Asia, and by 1972, the Navy's kill ratio had increased significantly to 13-to-1. Selecting a pilot for training at Top Gun involves far more than finding a pilot with the best flying skills in the squadron. Candidates, whether from the Navy or Marine Corps, must demonstrate excellent administrative and leadership skills, as well as a crucial teaching ability. In fact, it's more accurate to say that Top Gun trains the best teachers of fighter pilots in the world, rather than just producing top-notch pilots. The ideal Top Gun candidates typically have 400 to 500 hours of flying time and at least one sea cruise experience. These same qualifications apply to Top Gun instructors, who are selected not only for their flying skills, but also for their aptitude for teaching. Top Gun instructors typically undergo a 3-year tour at Miramar. During the first year, they focus mainly on learning how to be effective instructors. The initial 6 months of this period include a familiarization course on A4s, F-16s, and F-5s, which are the aircraft currently utilized at the school. Following the initial training phase, Top Gun instructors engage in sorties against other squadrons and participate in classroom sessions as either student instructors or student pilots. The comprehensive 5-week curriculum includes approximately 100 air engagements and 90 hours of ground school. The courses cover the majority of systems used in combat, ensuring a thorough understanding of all relevant aspects.
Why do we talk about fighter performance comparison anyway? Well, the main reason we do this is that we want to determine what the strengths of our airplanes are, what the strengths of the bogies airplanes are. Okay, general rules of the road. If you're head on, each aircraft bears to the right or a 4-to-4 pass.
Here we'll take the trail man and fly to the echelon into the zinc, okay? If we've got a good system, pound that's hooking left every time. I really think we get the average guys, so they say we go for it.
Every flight, regardless of its routine nature, is meticulously briefed to ensure optimal performance and readiness. Top Gun emphasizes the importance of teamwork and teaches crews to identify and exploit their opponent's weaknesses effectively. Each crew works together toward a common goal: victory. This emphasis on collaboration underscores the vital role of teamwork in achieving success in aerial combat. For most of the younger fighter crews coming to Top Gun, the hard-to-detect F-5s, F-16s and A-4s are the nearest thing to the MiG family they've ever flown against. The camouflage paint schemes add complexity to the situation, necessitating extra vigilance and teamwork among pilots.
Back starboard, 010. 010 now, 3.5. 2.5 miles now, drifting to the right again. 020 at 1.5 miles. Roger, tally ho. Got the hot stop the tally on him. Okay, tally ho, that's passing the left side now. Right side up on him. Right side. Okay, that pass up there.
We got it on the F-14.
Each maneuver the aircraft performs is meticulously recorded, computed and displayed on the TV-like screen of the Air Combat Maneuvering Range, ACMR. One of the standout features of the ACMR for pilots is its capability to serve as an instant replay device. During debriefing sessions following a mission, the entire team can gather to review their performance, analyzing it from various perspectives. Debriefing is a crucial aspect of every mission, allowing for a comprehensive examination of all engagement facets. This thorough review process helps identify areas for improvement and enhances overall performance. During debriefing sessions, pilots meticulously analyze what happened during engagements, how they unfolded, and perhaps most importantly, why they unfolded in a particular manner. They scrutinize details such as altitudes, contacts, and utilize fighter pilot language to reconstruct every dogfight scenario. As pilots review and discuss tactics that proved effective, as well as those that didn't, the process of growth at Top Gun begins. With each engagement, the student's ability and confidence steadily increases. Over time, the student begins to assert their leadership qualities, taking on more responsibility within the group. By the conclusion of the 5-week course, the student finds themselves assuming the role of an instructor, having developed the skills and expertise necessary to guide others through the intricacies of aerial combat tactics.
Element number 1 is able to take the offensive, begins to drive the fight. 5 and 6 are reacting to 1, maintaining good mutual support. Second blue element is back into the fight, again with good mutual support. Assisting with a shot. Cockpit view of blue number 5 as he's repositioned will assist his buddy number 6. See the missile fly out. Missile's off the rail. Second missile's off the rail. And the blue coffin indicates the kill.
E4 went to the right like we wanted him to. Up high here. We both made a call here. Good call on the 2B1 in the lead bogey. Okay. Morning. Today we're going to run our Alpha Strike. And this is the culmination of your training here at Top Gun. Your task today, fighters, is going to be to get a strike group on and off the target.
The Alpha Strike against a simulated land-based target serves as the culmination of the Top Gun course, offering students the opportunity to plan and implement everything they've learned over the preceding 5 weeks. During this exercise, the instructor staff acts as the enemy, challenging the students' ability to engage and neutralize enemy interceptors before they can reach the bomber force. While the combat capabilities of carrier-based fighters and attack aircraft like the Tomcat, F-18, A-6 and A-7 are well understood, a large-scale training mission such as the Top Gun Alpha Strike can uncover issues that may not have been previously considered. This exercise provides valuable insights into the effectiveness of tactics and strategies employed by the students, as well as identifying any potential weaknesses or areas for improvement in their approach. Top Gun aims to teach Tomcat drivers to become not only the best fighter pilots, but also the best fighter pilot training officers in the world. The goal is to develop a plan that will elevate their squadrons to the highest level of readiness, ensuring they're prepared to confront any adversary in any location where the Navy's carrier air wing may deploy. The strike against targets within the Navy's Tactical Aircrew Training Range in Fallon, Nevada, offers an opportunity to record the entire mission, facilitating detailed debriefing and the development of new, effective combat techniques. During these exercises, Top Gun instructors will pilot aircraft such as the F-5s, A-4s, and the newest adversary aircraft, the General Dynamics F-16 Fighting Falcon. The F-16, characterized by its small size, agility, and stealthiness, provides the Navy Fighter Weapons School with a realistic simulation of potential threats encountered in real-world scenarios. In addition to the F-16s, the F-15 Eagles from Nellis Air Force Base will also engage the strike force, adding another layer of complexity to the training scenario and further enhancing the realism of the exercise. This multifaceted approach ensures that participants are exposed to a variety of challenges, preparing them to adapt and respond effectively in diverse combat situations. This is a wrinkle that Top Gun students hadn't figured on. Indeed, one of the fundamental objectives of Top Gun is to imbue Navy and Marine pilots with an unwavering sense of self-assurance. A fighter pilot truly excels when their self-confidence is potent enough to dispel any doubts about their abilities and their aircraft. In the lightning-fast world of aerial combat, pausing to ponder the next move could spell disaster. However, with thorough training, sharp motor skills, finely honed reaction times, and steadfast self-belief, the subconscious takes command, enabling the pilot to react instinctively. This encapsulates the essence of Top Gun, immersing a capable pilot among the world's finest combat aviators, imparting the invaluable expertise that only seasoned minds possess. Through this process, Top Gun shapes pilots into elite warriors, equipped with the skills, confidence, and instincts needed to excel in the most demanding aerial engagements.
So we're going to be violating. Looks like that. I got him. Oh, no, fire. Walk that door high. You got to put your up in your line. So, okay, 8 pilot, that's time on the reverse. Actually, you need 5 nose down. And all on the get off tires. Take 30 on the left side. Might be that one. I got him. Can't minutes. F4 belly, left side, 10 o'clock. I thought you were going to come over here. You got to plug the high 8 o'clock. Right around think about 20 tires. I got this. So, I don't want to do that's what's in the inside the three. I'm going to kill him. I'm just going to fight. Okay, got 13.
Oh, let's bring it left. We're going to got 14 behind us. Bring it left.
Wow.
But you're ready for a target. Yeah, Charlie, always goes in on it. Trouble here. She's got about 50 to go with it. Okay, bring it back. Starboard, dog.
Oh, you're about to
It's crucial to instill in them the understanding that the fundamentals of aerial combat haven't drastically evolved since 1918, aside from advancements in speed, altitude, and the destructive capabilities of weapons. They must grasp the reality that their adversaries possess similar motor skills, reaction times, and knowledge. What sets them apart is rigorous practice and comprehensive knowledge. Only through dedicated training and continuous learning can they prepare themselves for the daunting task of piloting a supersonic aircraft and engaging in combat against equally skilled opponents. It's a relentless cycle of training, honing skills, and accumulating knowledge. On board a 90,000-ton supercarrier, the intensity of training is palpable, with 1,000 feet of steel deck, braided cables, and the swift movements of deck crews clad in yellow shirts, ensuring safety during rapid takeoffs and landings. In round-the-clock training exercises, pilots repeatedly face challenges, refining their abilities and readiness for any situation they may encounter in the skies. 17 stories from superstructure to engine room, with a population of more than 6,000 specialists who run this city and manage its air wing of some 90 aircraft. The nuclear-powered capability of the carrier provides unparalleled operational flexibility, enabling sustained high speed and maneuverability, with enough fuel to remain at sea for an impressive 13 years. It serves as a self-sustaining mobile fortress, dedicated to the primary role of projecting US air power with a rigorous training regime for its aircrew. Preparation for the carrier's aircrew involves daily flights, sometimes even twice a day, to hone their skills in various scenarios, including radar intercept, air-to-air combat, strafing towed targets, bombing land targets, and anti-submarine operations. While deployed at sea, Tomcats, along with the E-2C Hawkeye, serve as the long-range eyes of the carrier battle group, tasked with identifying and neutralizing any hostile threats. This capability was demonstrated in January 1989 when Tomcats engaged 2 Libyan MiGs, highlighting their role as guardians of naval supremacy. What you're about to hear is the actual radio transmissions between the 2 prowling Tomcats flying combat air patrol and E-2C Hawkeye and the carrier John F. Kennedy. You can assess the outcomes firsthand.
Contact of 175, 72 miles. Looks like a flight of 2, Angels 10. Close out concurs, show at 78 miles. James Cornell shows 25 miles separation, turn it down. Contacts appear to be heading 315 now, speed 430, Angels approximately 8,000. Roger, Ace, take it north. 330. Bravo, let's close out. Come back towards 23. Jenkins now, okay, bogies appear to be coming, jinking to the right now, heading north. Speed 430, Angels 5,000 now into descent. So let's take her down now, we're going down. Okay. Shows us 53 miles now. Bogies appear to be heading directly out as I'm coming toward. Steady up 150 for 30-degree offset, 50 miles. Angels 9, I'm going down to 3. Cross back over. Roger. Roger that. 30-degree offset now. Bogies heading 340 speed, 500, let's accelerate. Okay, we look like they're good now. Roger, bogies have jinked back into us now. Let's come starboard 30 degrees the other side. Angels, James, join up set station. Roger, Angels now 11. Steady up.
Close out, warning yellow, weapons hold. I repeat, warning yellow, weapons hold. Alpha Bravo out. Roger, Gypsies. Pass up, Bravo directs, warning yellow, weapons hold. 35 miles here.
Roger that. Bogies have jinked back into me now for the third time. The nose is on at 35 miles. Angels 7.
Bravo, close out, you copy?
Taking another offset, starboard 210.
Yeah, I got one FBO's 30 miles and he's a 13,000 piece of trailer.
Roger that. Level off here. Okay, bogies jink back into me for the fourth time. I'm coming back starboard. Come back port now. Port, 27 miles. Bogies at 7,000 feet.
Port 5. Want to set up bogies 135, 50 Angels 16. Heading 340. Okay. Roger, say bogies. You're in collision now. Hearing.
Okay, bogies have jinked back at me again for the fifth time. They're on my nose now. Inside of 2 miles. Master arm on. Master arm on.
Take good light. Good light.
Okay, centering up the T. Bogey has jinked back into me again. 16 miles, it's centered to back.
Say your Angels.
I'm at Angels 5, nose up.
Oh, his Angels. Well, wait a minute.
Angels are at 9.
Alpha Bravo from 207.
13 miles. Fox 1, Fox 1.
Beacon right.
Roger that. 10 miles, he's back on my nose. Fox 1 again.
Watching them up.
6 miles, 6 miles.
Alley 2, Alley 2. Turning into me.
Roger that. 5 miles. 4 miles.
Okay, he's got a missile out. Breaking right. Good hit on one.
Roger that. Good kill, good kill.
I got the other one. Short box 2, short box 2. I see jumping out of the trailer. Coming hard,
Stop him up.
I haven't got Colin.
That's the second one.
I got the second one on the nose right now.
Hey, I'm high cover on you.
Get a lock him up.
Stop him up.
Man, short box 2. I can't. I'll have a fool. Good kill.
Hey, good kill. Quality tested.
Be careful down in the second one. Okay, Maestro, let's head north, head north.
Two fighters flash. Close out, we're heading north.
Roger.
Roger that. Gypsies are going north. Let's go down low, out of deck. Unload 500 knots. Let's get out of here.
The world's premier interceptor, the F-14, has undergone modifications to ensure its effectiveness against any potential threat. The introduction of the new F-14D was part of a two-phase program. Initially, an interim version, the F-14A+, was delivered starting in April 1988. This enhanced Tomcat retains the F-14A airframe, but is equipped with the more potent General Electric F-110 turbofan engines, boosting available thrust from 42,000 to 56,000 pounds. The first F-14D deliveries, incorporating the upgraded engines alongside digital avionics and enhanced radar systems, took place in March 1990. These advancements signify a significant evolution in the capabilities of the F-14, ensuring its continued effectiveness in countering evolving threats. Despite efforts by the Pentagon to limit the F-14D program, Congress allocated funds for the acquisition of an additional 18 newly manufactured Tomcats in fiscal 1990. However, the Navy is contemplating stretching out production timelines as it grapples with reconciling its ambitious modernization initiatives with projected budget constraints. Aircraft procurement strategies are under review as part of the Navy's Carrier Air Wing Study 2010, aimed at aligning the service's needs and acquisition plans with available resources. This comprehensive assessment seeks to ensure that procurement decisions are in line with the Navy's long-term goals and fiscal realities. A Navy version of the Air Force's Advanced Tactical Fighter, which would replace the F-14 fighter, is one of the service's highest priorities. The Navy is collaborating closely with the Air Force to develop a carrier-capable variant of this new fighter aircraft. Additionally, the Navy is evaluating a proposal from Grumman to enhance the F-14D into what is being termed the Century 21 Tomcat. Grumman's proposal involves modifying the F-14 airframe to minimize the aircraft's radar signature, integrating enhancements to provide ground attack capabilities, and potentially installing an upgraded engine to extend its operational range. These upgrades aim to modernize the F-14D and enhance its versatility for future missions. For years to come, the F-14 Tomcat will maintain watch over 3 oceans, serving as a formidable presence capable of preserving peace or altering the course of conflict, and above all, remaining ever prepared.
Today, there is much excitement about self-driving cars. But back during the Vietnam War, the Navy had an aircraft that could virtually fly itself. After dialing in the coordinates, a pilot could rest assured he and his payload would arrive right on target. It could even land itself on the deck of a carrier. With all its advanced features and its rock-solid design, this aircraft served double duty in the U.S. Air Force for close support and treacherous rescue missions. Conceived by the brain trust of legendary aircraft manufacturer Vought, it was an aircraft for its time and ahead of its time. This was the A-7 Corsair II. By 1963, the U.S. was heavily invested in the Vietnam War. A year earlier, Kennedy had signed the Foreign Assistance Act, offering military aid to nations on the edge of communist expansion. South Vietnam was embroiled in such a conflict as hostilities intensified with the communist North. The Americans made good on their promise, providing the South Vietnamese with equipment, training, and a growing number of military advisors. With an all-out war almost inevitable, the U.S. Armed Services began prepping for battle. The Navy was looking to replace their aging Douglas A-4 Skyhawk. It was a small, subsonic bomber, capable of carrying the same payload as the B-17 bombers of World War II. The Douglas Aircraft Company had manufactured the original A-4 Skyhawk, and they were eager to remain the Navy's light bomber manufacturer. They offered the simplest solution: build a better A-4. and they hoped to circumvent the usual competition for such contracts. However, other manufacturers, including LTV Aerospace, would not stand to be shut out of the